Anyways, here we are, the June 2022 math grade 12 paper 2 memo. So obviously we're going to go through everything from the beginning, and here we are. So question 1 here says, right, the table below shows the mass in kilograms of the school bags of 80 learners. Ooh, so these are the smart guys, eh? No. Yeah, whoever these people are, the smart ones, you see. No, wait, what am I saying? This is the mass. So obviously 5 kgs to 7 going on. So the higher the kgs, probably the higher the books. You see, that's why there's fewer people. So like, I mean, like usually the people that carry their books are the ones that do well, you know. So don't be that person that doesn't carry their textbook because you're just gonna borrow it from someone. You know, that's just being dumb. Yeah. But anyway, what am I saying? Let's see. It says here, write down the model class of the data. So the model class basically refers to the class where you have the highest frequency. So the model class is between 9 and 11 here. So your model class here, you're gonna say here 9 big is the mass has to be bigger than 9 and it has to be smaller or equal to 11. That's the model class. Moving on. It says here, excuse me, calculate, it says complete the cumulative frequency column in the table in the answer book. So the cumulative frequency table, it's almost like what you may call, let me actually just copy this and actually paste it here, because it would somewhat be an additional column to what you have here. So the cumulative frequency, it's literally what you get as you will be adding these frequencies together bit by bit, you see. So let me write here Q, hey, there's this thing so big now, 14ish. Fine, let's just leave it at 10. So Q mu, how do you spell cumulative frequency? I actually don't need to spell it, but might as well. Q mu lative frequency. Excuse me, here. Frequency. So the cumulative frequency is going to be an additional it's going to be an additional column here. So let's see. In the beginning, you will have 6 only, like 6 people that have a mass between 5 and 7. So the total you have so far is like 6. From 6, you're going to add 18, right? So let's see what that is. 6 plus 18, give us 24, plus 21, it's going to give us 45, plus 19. Okay, calculator, help us please. It's going to give us 64, plus 11, that's like 75, plus 4, that's 79, plus 1, that's like 80, which makes sense, you see. So this column here, you can see it has to add up to 80 because we are told that we have 8 learners to begin with. So that's fine, that's going to give us 3 marks. The next question here, they want us to draw a cumulative frequency graph for the given data on the grid provided in the answer book. So your OGIVE, right? You're going to have to remember that your classes, right, is what you put down here. So let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think 19 is going to fit here. So let me put 0 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. But wait, why am I making life difficult for myself? Huh? Just make it easy and do what they have there. Bruh, come on now, come on. Oh yeah, but anyways, I have to still count from 1 to 1, 2, 3, 4, 5, right? Then it's like 5 to 7, 7 to 9. So it's jumping every 2. So let me see here, 5 to 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 is going to end over there. Okay, fine. So your OGIVE always has to start from 0. Now the thing with drawing what you may call an OGIVE is that you always need to use the midpoint of each of these for you to plot your points, you see. So the midpoint of like 7, 5 and 7, it's like a 6. Here it will be 8, 10, 12, 14, the middle here is 16, the middle here is 18. So obviously to get the middle, if these numbers are not so simple, you just add the 2 and you divide by 2. You see, that's how you get the middle. Just like here, 5 plus 7 is 12 divided by 2, that's a 6. So when you plot, right, you plot this, this is more like going to be your x-axis, and then the data in your cumulative frequency column is going to act as your y-axis, you know. So 6 and 6 is what we plot first, right? So technically, this is going up to 80, right? So we have to be careful here. Let's see. I think here we're gonna have to jump in, I don't know, tens. No, tens. But no, 2, 4, no, I think 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. Yeah. Then we're gonna have to jump in fives, you see. So yeah, yeah, ne? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, and then 80. Okay, so let's plot our points. You see, the first one is 6 and 6. So 6 and 6 would be somewhere, 6 is here, 6 would be like somewhere there. And then you're scrolling up and down. So it's 8 and 24 here. So 8 is like here, 24 would be like just before 25. And then it's like 10 and 45. So 10 here, 45 would be like somewhere over here. And then it's like 12 and 64, 12 and 64, 12. 64 is like somewhere here, just before 65. And then we have here 14 and 75. So it's like 14 here and 75. That's like there. Perfect. And then what? Then here we have 16 and 79. So 16 and 79. So 16 is in the middle here. 79 is like there. That's the way we like it. And then lastly, 18 and 80. So let's see here. There's 18 over here in the middle. And then 80 is like right there. Wow, we have nice looking points. Because for once we did not just, you know, draw our own. We have a grid. So joining these, you want to just make sure your curve is a bit smoother. This has to start directly from 0. So let's do this. Connect these here. Do that. Ooh, this is looking out very nice. Oh, wow. Okay. Is a nice looking archive. So that's going to give you 3 marks. The next question says, for 2 marks, use the graph to determine the median mass of the data. So when they speak of the median mass, so they mean if you were to sort out these masses, right, from the smallest to the biggest, you see, you would write, the first 6 people would line up, and then the next 18, and then 21 people afterwards, and then 19 people, and then 11, and then 4, and then 1 person. So when you put them in a line, right, the person in the middle is the person that's going to be like at position number 40, you see. So yeah, one or the other, if you're going to get the median, you know that between 0 and 80, right, the median is technically Q2, you see. So Q2, you know that the position of Q2 is always given by 2 over 4 and then n plus 1, you see. So in our case here, we know that this is like a half. N is the total for your data. This in the calculator, let's see what it is giving us. 0.4 times 80 plus 1. That's like 40.5, you see. So that's like 40.5. 40.5. So 40.5, you want to go to your archive, right, where 40.5 is. So it's relatively close to where 40 is, obviously. And then what you do is you trace that to your graph, and then you trace that down to see which class that falls under. See, so it's between 9 and 11. So if you look at the question, you see, use the graph to determine the median mass. So the median mass is between 9 and 11. You see, the mass has to be bigger than 9 and smaller or equal to 11. That's the median mass. So, or you can even approximate it, you see, approximately equal to 10. Approximately 10. Let's see, 1.5. The international guideline for the mass of a school bag, is that it should not exceed 10% of the learner's body mass. Ah, what a wow. And then they say here, calculate the estimated mass, no, calculate the estimated mean mass of the school bags. The question is, the one thing that's weird about this question is, I'm asking myself, how is this relevant to the whole international guideline? What? Like literally, I'm really asking myself, but I have to read the question again clearly, since, you know, they probably told us that for a reason. The international guideline for the mass of a school bag is that it should not exceed 10% of the learner's body mass. Okay, so we could assume that our bags don't exceed 10% of the learner's mass, but it says here, calculate the estimated mean mass of the school bags. Yeah, to be honest, this question low-key almost has nothing to do with this question, because it's like, what? So what if that's the international thing? Fine, it's a law or whatever, but I mean, for this question, it really doesn't look like this is useful, unless I'm like missing something, but I doubt. Now calculate the estimated mean mass of the school bags. They could have literally just skipped out this, or maybe for the follow-up questions. Oh, there's a 1.5.2. Okay, maybe we'll do the whole, we'll use this information for the next question. But for this question, we really don't need this whole thing here. So to calculate the estimated mean mass of the bags, funny enough, you can just use your calculator here. You know, you have to just use your calculator here. So to use your calculator, you need two things. You need the midpoint, and you need the frequency for you to use your calculator to get the mean. And this is how you do it. And this is quite, let me just see here. Let me get this calculator so that we can do the does, you know. So the first thing that you want to do when you what you may call, when you're going to get the mean using your calculator, this is what you do. You have to press shift mode. So let me write here, shift in your calculator, and then you press mode. So let's put here mode, and then you're going to scroll down. After scrolling down, you click on stat, and then you have to click on frequency. So no, if you click on stat, right, it's gonna bring out frequency, and then you say on. You have to switch on the frequency. So you obviously press 1. See, after you switch on the frequency, you wanna do the following. See, you're gonna now press mode again, and then you're gonna press stat. After pressing stat, you're gonna press what you may call var. Gonna press var here, and then two columns are gonna pop out. There's going to be one showing you x, and then the other one showing you frequency. X and frequency. So the column where x is, you're gonna put in your midpoints, you see, which is 6, 8, 10, 12, 14, 16, and 18. So let's do that. You see, 6, 8, 10, what is it now? 12, 14, etc. Going on and on and on and on. And then the frequencies, it is 6, 18, 21. Let me just put that here so that you can see it. 6, 18, 21. Going on and on and on. I actually need to put this in the calculator, you know. So let's see, 6, I would rather put in the midpoints first and then go back up and put the frequencies. So 6, 8, and then 10, then you just keep pressing equal to, 12, and then equal to 14, equal to 16, equal to 18, equal to, let's see how many we have, 1, 2, 3, 4, 5, 6, 7. Yeah, that's fine. Then we're gonna go back up to the beginning, go to the frequency column, and then we're gonna put the 6 and then equal to 18, then equal to 21, 19. Trust me, this is much better than doing it manually. So then 4, then 1. Okay, perfect. So once you've put in all that data in your calculator, right, you're gonna press the on button. Let me use a different color here. You're gonna press on and put here on, and then you're gonna say shift. Gonna press shift and then the number 1 button, the one that has a small stat thing on top of it. And then you're gonna click on var. And then from there, you're gonna click on option 2, which is gonna give you mean. So the mean here is 10.68. If you round off by 2. Wow, this is quite interesting, man. Wow, what damn, son, where did you find this? Yeah, I'm imitating this sound from this podcast, but I probably sounded like a mad person. But anyways, hey, we got the answer right, so I guess that counts for something, hopefully. But yeah, moving on. The mean mass of this group of learners was found to be 80 kilograms. What? Hey, these kids are heavy. Oh, wow. What kind of a mean mass is? Because this is like the average weight. No, are these like adult students or what? Because this doesn't make any sense, bruh. But hey, let's stop and let's stop being psychotic. The mean mass of this group of learners was found to be 80 kilograms. On average, are these school bags satisfying the international guideline with regard to mass? Motivate your answer. So they said here, the international guideline says that the mass of a school bag, it should not exceed 10% of a learner's body mass. So it should not exceed 10% of a learner's body mass, right? So what we know is that 10% of 80 kilograms, let's see what that gives us. 10% of 80 in the calculator is going to give you 8. You see, so the bags do exceed the international guidelines. So here we're going to say, they said, are the schools bags satisfying the international guideline? We're going to say no, because 10% of 80 kilograms is below the average. Yeah, let's just use the numbers. No, because 10% of 8 kilograms, let me write this kilograms a bit better. No, because 10% of 80 kilograms is not below 10.68. You see, because remember, 10.68 is the average for the bags, and then this is what the bags should actually weigh on average. So on average, nope, these the weight of these bags are not satisfying the guidelines. So that's how you're going to answer that question. Whew, okay, let's move on to question number 2. Question 2, we're dealing with a scatter plot as expected, because it's always like that. Anyways, it says the size, or the table shown, the table below. Okay, the table below, this table here, the table below shows the size in carats and the price in rands of 10 diamonds. Ooh, 10 diamonds that were sold by a diamond trader. So we have a diamond trader, and this diamond trader basically has 10 diamonds, and then these are the carats of the diamonds, and then this is the prices at which they were sold. So before even doing anything funny, we can already see that as the number of carats increase, the price for that diamond is also increasing, which is like duh. So that information is important. And then it says here, this information is also presented in the scatter plot below. The least squares regression line is also drawn. So the least squares regression line is more like a line of estimation to say that this is how the data is behaving. So this is quite straight, so our correlation coefficient is also going to be quite high. But anyways, let's see. 3 marks, it says determine the equation of the least squares regression line of the data. The equation of the least squares regression line, we can just get that from the calculator by putting in this data in the calculator. So we actually need to do it, So in the calculator, you kind of need to make sure your calculator has been cleared. To clear your calculator, you have to press shift and then number 9 to clear your calculator, Let me actually just write it up here, you see. To clear, right better, my guy. To clear your Casio calculator, your Casio calculator, press shift, then 9. Yeah, press shift, then number 9. Okay, there we go. Perfect. So that being said, yeah, you have cleared your calculator, right? So now you need to put stuff in it for you to be able to get the least squares regression line equation. So here, what are we gonna press? You're gonna press shift mode. No, you're gonna press mode only. Yeah, I was getting lost here. So you're gonna press mode, and then you're going to press stat, and then you're gonna press a plus b x, and then you're gonna press so this column is gonna come out, right? So this column is, these columns is where you're gonna put in your values, right? So the values you're gonna put in are these here from your data. So already here is they've given you x and y nicely. So let's put that data. So I'm gonna put in the x values first. This is 0.1 equal to 0.15, 0.12, and another 0. Right, no, it was 0.2 twice, and then 0.3, so, and then 0.35, 0.4, 0.45. So with questions like these, yeah, you definitely want to make sure that the stuff that you're putting in the calculator, you're not like making a mistake, since you're also working with decimals. So yeah, let's go back up to the top in the calculator, and then in the column where there's y, we're just going to put these values here: 4,000, 6,000, 6,500, 8,400, and then what, 9,000, going on and on. So obviously in the stats section, right, that's like the portion where you really just want to milk the marks. Like, to be honest, in the stats section, at least a good 90% of the marks minimum is what you should always aim for, because most of these marks are literally just given away, So let's see here. The last one here is 18,400. Okay, let's see what we get. So all this, when you're done now, you're gonna have to press the on button, because most people don't press the on button, and then their data disappears, you see. So you're gonna press on here first. After you press on, you're gonna press shift, and then you're gonna press stat, which is the number 1 button in the Casio calculator. And then let's see here, shift stat, you're gonna press reg. The last time we pressed var, you see, but now you have to press reg for least squares regression line. So after you press reg, you're gonna get an a value, and you have to obviously get the a value first and then the b value. You just repeat the process. So a here, it's gonna give you 655.96, which is kind of believable because we are kind of working with, big values here, you see. But then the value of b should reflect this kind of data up there. But let's see. Shift stat reg B. Yo, I lied. B. Yo, but this is not making any sense, eh? Yeah, it's not making any sense at all. No. It is. Because no. Remember this scale here is actually quite crazy, because you see, look at where 0.1 is. 0.1 is at like 4,000. So the value of B, you can expect it to be quite large. Let's see here, 32,095. So this is definitely realistic. Reason being, the scale here, you can see it's so ridiculous. You don't even have 0 to 1, you see, but you're already dealing with 20,000. So a very high value of B like this is normal, because remember, B almost like gives you an idea. It's almost like the gradient, if I can put it that way. Low key it is actually. So anyways, this is the values of A and B. So the equation of our data, let's see here, y is equal to A is like 655.96 plus B is like 32,095, and then X is there. Whew, must be nice. And then it says for 2 marks, if the trader sold a diamond of, if the trader sold a diamond that was 0.5 carats in size, predict the selling price in, so the selling price of this diamond in rands. So the selling price, it's all based on your equation. So in your equation, they've given you the carats, right? So remember, the carats represent the X value. So an X value, you're gonna throw in an X value of 0.25. And then this is gonna give us a prediction of the price, you see. That's how this equation works. So let us see here, 5.38. X value is 0.25. So, okay, is good. 655.96 plus 32,000 and 95, 0.25. That's like 8,600 and something. Y is equal to 8,679.71. There you go. That's the way we like it. Okay, moving on. It says calculate the average price increase per 0.5 carat of the diamonds. Ooh, yeah, now we're talking. It's just a 2-mark question, but yeah, this question you kind of do need to think, you know, like, because it's not that straightforward. But let's see. Calculate the average price increase per 0.5 carat. Okay, so if we're gonna calculate the average price increase per 0.05 carat, yeah, what are we gonna do? Because I'm actually thinking to myself, it's just a 2-mark question, yes, but oh, excuse me. But yeah, kind of need to think what I feel like there is a very simple way to think about this question, because firstly, the fortunate thing is, remember, our if you look at our scale here, this scale is going in 0.1 every time. Remember, in the middle of 0.1, you would technically have 0.05, you know. So this is 0.05, and then you add another 0.05, add another 0.05, add another one, going on and on and on and on and on. So our scales somewhat could help us to figure out the, what you call, the average price increase per 0.5 carats. Because remember, if you look at our scale here, in the middle here, as I said already, this is 0.05. And then you add another 0.05, you get 0.1. If you add another 0.05, you're going to get 0.15. If you add 0.05 to this, you have technically 0.25. So in the middle of all these, right, you have these values here. So the reason why these values are important, or the reason why I'm putting them here, is so that you can see what we're going to do to work out this 2-mark question. So for this 2-mark question, what you can see is, right, logically speaking, for every 0.05, right, it's a price increase of 2,000, you see. So that's basically the idea behind what we're seeing here. For every 0.05 carat, the average price increase is 2,000. You see, that's what you want to keep in mind, because if it was double 0.05, then it's like 4,000. If it's like triple 0.05, then you can see it's roughly 6,000. You see, so the average increase there is just 2,000 per 0.05. You see, so let me show you. See, for 3 times 0.05, it is 2,000. You see, I mean it's 6,000. So here it's 6,000, whereas this is like 0.15. Here for a single 0.05, it's just 2,000. You see, so that's how we can get these easy 2 marks here. So the average increase for every 0.05 is just 2,000, because here you increased by 0.05 3 times. You see, 1, 2, 3. So you increased by 2,000 3 times also, 1, 2, 3. And this is giving you a nice accurate way, because it's not exactly on the line, but it's remember working with on average. You see, so for 2 marks here, you're gonna have to say R 2,000 per 0.05 carats on average. You don't even have to worry about the language here. You can just say 2,000 and you get your 2 marks, like literally. Okay. 2.4 says, it was later found that the selling price of the 0.35 carat diamond was recorded incorrectly. The correct price was 11,500. Let's see before we even finish reading. 0.05, they say this was recorded incorrectly. They say the price was actually supposed to be 11,500. So for a single mark, let's see here. It says, yeah, the correct price was 11,500. When this correction is made to the data set, the correlation between the size and the price. No, when this correction is made to the data set, the correlation between the size and the price of these diamonds gets stronger. Explain the reason for this by referring to the given scatter plot. So the easiest thing to do is refer to the given scatter plot, as they said. So remember, 0.35 carats, on the scatter plot, it's plotted at 10,000. If you look here, 0.35, right? It's plotted at 10,000. This is the wrong one. But then the correct one, they said it's 11,500. So if they had plotted it at the correct place, it would be 11,500 would be like somewhere there. The reason why the correlation coefficient would be stronger is because this point is closer to the least squares regression line. Least squares regression line. And I'll explain why just now. So as long as this point is closer to the least squares regression line, it means that this point is somewhat more in line with the rest of the data, you see, because this point is a bit lower. So obviously, even if it was maybe like 12,000, that was the correct one, then it would make your correlation coefficient higher. Because remember, the words correlation coefficient, it's just referring to the level of intensity of how the data somewhat is linked, of which, in simple words, right, what we're seeing here, as we said in the beginning, the higher the carat, the higher the price. And you having to have had a size of like 0.35, we would be expecting a slightly higher price also, you see, because as the number of carats are increasing, the prices also need to be increasing. So here, this price not having to have increased as well, or not having to have increased as much, it's still okay, but this one here, that's the accurate one, is actually contributing more to our correlation coefficient being higher. So in simple words, right, for 1 mark here, we're just going to say because remember the question here said when this is collected, blah 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 blah, correlation between the size of the price, the correlation between the size and the price of these diamonds gets stronger. Explain why. So we're saying here because you can say something, you just say something very blunt, because the point on the scatter plot would be closer to the least squares regression line. There you go. Least squares regression line. Boom. Very simple. And you move on. You keep moving forward. So let's move on to question number 3 now. Here we are, question number 3. So question number 3 looks pretty interesting. And I should have like highlighted what question number 3 actually looked like. But then I'm pretty sure you can see what they'd originally given us, because in addition to this, there is, you know, what was drawn by the person that was like going through this paper. So let me just, you know, give an idea of like what the sketch looked like. Maybe make it a bit brighter, you know, so that we can see what was given and what was actually just drawn during like the exam. And you're probably thinking to yourself, but bro, why didn't you just do this before the paper, bro? Why are you doing it now? Ish, sorry, yammer. But don't worry, I am almost is done now, so you know we can start now. See, let's just make this a bit longer. Come on, man, come on, guy, cooperate, comrade. Anyways, this is fine, right? So they told us that we haven't read the question yet, but then I'm trying to make sure that we draw these nicely, because they say these are parallel, so these are equal. Anyways, so they say it here in the diagram. A is, where's A? A is this coordinate, B is this coordinate, and then C and E are the vertices of a trapezium. So C is here. C was not given. We'll have to see if this is actually the coordinate of C. E, A, and B were given. So these are all vertices of a trapezium. They said here A, they said BA. Where's BA? BA is here. It's parallel to CE. D is the y-intercept of CE. So where's CE? CE is here, right? And D is the y-intercept. Then they said here CD is equal to BE. These are equal to each other. What a wow. So I probably should have like erased a lot of this stuff, but I don't, it's fine. It's not that distracting. So they said we should get the gradient of AB. So getting the gradient of AB is just the gradient formula, you know, very easy marks that they like to offer us in these paper 2 question papers. So the gradient of AB is going to be equal to y2 minus y1, x2 minus x1. Perfect. So with that being said, right, what else do we need? What do we need? We need, let's see, this is going to be 3 minus a half. So 3 minus a half, and then 5 minus 0. 5 minus 0. Perfect. What else now? So 3 minus a half and then 5 minus 0, right? So in the calculator, you have to clear your calculator again, because hey, sometimes you're going to not be able to use your fraction buttons. So 3 minus a half, and then down there 5 minus 0. I literally put a 0 in the calculator because it's not a problem. It's just for the vibes, you know. So yeah, that's just the half. The gradient here is a half. So remember, down here, the gradient is also a half. Should we ever need it? What is next? I can't believe I put a question right here. Wow. Okay. Determine the equation of CE. CE is the line down here. So remember, as long as you need the equation of a straight line, you can always use this format here. This format is like the stuff of dreams, because all you need is a gradient, which we already have. And then all you also need is a coordinate that the line passes through. So a coordinate that the line passes through here, we have E, you see, 6 and -4. So E is 6 and -4, right? So all that information we can throw in here, because this isn't this for x1 and y1. So here y1 is a -4, right? So if you put a -4 there, you'd plus. Gradient is a half, and then x1 is what? 6. Fantastic. Is good. And then what do we have to do? This is the 4 is going to go to the other side. It's going to become a -4, right? But then here it's a half times x, right? Which is half x, half times -6 is like -6/2. When this comes over, it would be a -4. And then here this is a half, right? Remember, this is like -3 in the calculator. So -3 minus 4 gives you a -7. And then there's the equation of your straight line. You get yourself good 3 marks there. 3 more marks, they say we should calculate the coordinates of C. Where is C? C is here. The fortunate thing is, remember, this is the y-intercept. So yes, definitely this y-intercept is 0 coordinate -7, because it's a point on the y-axis. So the x value is a 0, the y value is a -7. But then if you need to get C, right, for you to get C, you can use the midpoint formula. What I mean is, your straight line looks like this, right? D is in the middle here. It is 0 and -7. Here is what is that? I think it's E. E was here. I don't even know I drew it like that. Oh, right, it is like that. It's 6 and -4, right? And then here you have a coordinate missing on the other side. You can label this x2 and y2. So you can actually label this x1 and y1, and then these are the x and the y values of the midpoint. So doing this, what's important is to remember that when you use the midpoint formula, remember the midpoint formula, it can be used in two parts. The x value of the midpoint is just x1 plus x2 over 2. The y value is just y1 plus y2 over 2. You see, it's two separate formulas. So those two separate formulas that give you an x value of the midpoint and the y value of the midpoint, you can just use them to get these two individually. You see, because x1 you have, it's a 6 there. x2 you don't have. And then you can just solve for x by, okay, the x value of the midpoint here is a 0, right? So x value is a 0, and then x2 you don't have, but then x1 you have there, it's a 6. So you just put that in information in here. We have x, we have x1. So we're missing x2 here. So here we can just multiply both sides by a 2. And then you are going to get, what are you going to get? Oh, I think you're going to get a 0, bro. Like, wow, I can't believe I thought about that. And then 6 plus x2 here. The 6 goes over, becomes a -6. I'm wondering why I'm writing this slanted, but it's like, my hand is slipping. It's about to fall. But let's see. So here, y is like -7. y1 is like -4. y2 we don't have. Anyways, then here you're going to multiply both sides by 2, right? So this is like -14. And then this is like -4 plus y2. And then here the -4 goes over. You're going to have -14 plus 4, which is -10. Fantastic. Let's see if these are accurate. So -18. What? Nah, fam. Unless I made a mistake somewhere. Let me actually just double check my answers. Let's see. Y value is a -4. Is it a -4? Yep. Oh, if you put a negative, yeah, wait, -4, and so the 4 would, if it multiplied by 2 on both sides, is negative what? -14. So if you move over to the other side, it would be a plus. So -14 plus 4. Yeah, I think here the mistake this person made was, they kind of added the -14 and the 4. But anyways, if you take it over, you'd be -14 plus 4. So it's a -10. So therefore, the coordinate of C is x value is -6, y value is a -10. Get the area of quadrilateral ABCD. You want us to get the area. Ish, I don't know why this question is here when it's supposed to be here, but yeah, ne? Our quadrilateral ABCD is a trapezium. You see, ABCD is a trapezium. The area of a trapezium is as follows. You see, the area will always be a half multiplied by, let me just put it here, a half times the sum of parallel sides multiplied by the distance apart. I don't even know why I'm writing so spaced out like this. You know, it's kind of weird. I'm also writing another color that's not red, because red is weird to write in. So the area of a trapezium, it's a half multiplied by sum of parallel lines multiplied by their distance apart. You see, so let's put here multiplied by distance apart. So this is a simple formula that you can always just remember. I might as well make this a bit bigger now, since everything kind of fits. Okay, so the sum of our parallel lines. So firstly, we need the distance of each parallel line. You see, so we need the distance from here to there, the distance from here to there, and then we add it up. The distance apart, yeah, that's gonna be something we need to get. So for you to get the distance apart, the issue is that distance has to be a line perpendicular to the parallel lines, literally. So yeah, but then wait, did they say this is a trapezium? Oh yeah, perfect. The moment they say this is a trapezium, right, it means that this is a 90-degree. Oh no, it doesn't. Baga. Snap. I'm held in a chalk slam here. Oh, this does not mean it's 90. This could easily be 90, right? If we can prove that this is 90 degrees, then we would be able to use this distance as the perpendicular height, you know, or as the distance apart the parallel lines. You see, so let's just see the gradient of AE, because if remember, the gradient of AB is like a half. So if these are perpendicular, it means that there are two gradients multiplied by each other gives you a -1. So let's just get the gradient of AE, because we kind of need to do something before we can use this formula. So the gradient of AE, let's see what it is giving us. It would be -4 minus 3. Let's see here, -4 minus 3. And then the x values would be 6 minus 5. 6 minus 5. This is like -7, and then 6 minus, whoa, error. Already something is wrong. Unless, well, if these are not perpendicular, then I mean, it's fine. We'll have to use another way, because okay, this minus this is giving us -7. This minus this is giving us -1. So the gradient here is a -7. And then obviously, if you multiply a half and a -7, it does not give you a -1. So it seems as though we may not even be able to use this equation of a trapezium formula, because of getting the distance between our parallel lines here. I think getting the distance between our parallel lines is going to be a bit of a problem. It's going to be a bit of a problem. So it looks as though getting the area of this trapezium. Oh, excuse me, there's a yawning here. Let's see, it's a 4-mark question. So the first thing is, even though I thought of this, right, of this formula, I mean, before we give up on it, excuse me, we kind of need to see, is there a way to get the distance apart these parallel lines? So the way it's given, I don't think so. So we might have to forget about the whole what you may call equation of a trapezium formula. But then it is a 4-mark question though. So it being a 4-mark question, I'm thinking to myself, yeah, we really don't need to stretch ourselves too much. But then the other thing also is, yeah, I don't know. We have to think here. We really have to think. We need the area of A, B, C, D, A, B, C, D. So I'm thinking of splitting it up into like maybe excuse me. I'm literally going through this paper in the night, so I'm like, ay, come on, man, come on. Determine area of quadrilateral ABCD for 4 marks. Okay, so no, this is the train of thought, or this is from past papers what I normally do, like from going through different papers. Normally these kinds of questions, or any question that seems a bit difficult, what you can try to do is just look at the questions you would have recently answered. Like here, we recently got the value of C, right? Before that, we got the equation of CE. Before that, we got the gradient of AB. So let's see how those pieces of information can help us, because they should be able to help us some way, somehow. You know, they really should be able to help us some way, somehow. So yeah, how can they help us though? The gradient of this line here is fine. It's all nice and dandy. Yo. Hallelujah. Hallelujah. Oh well, yeah. I mean, if all else fails, let's see what the next question is actually. The next question is talking about K and then perimeter and then, yeah. So I think the sad thing with this question is it's only out of 4. So if it was, let's say, maybe more than 4, I probably would be thinking of doing some crazy stuff. But for now, just because it's out of 4, yeah, I'm trying to keep it simple. But trying to keep it simple is probably what is probably going to be a problem. But then let's see if there are certain ways we can cut this shape in half and then get the area of some kind of a triangle, and yeah. So let's see what happens when we have let's see what would happen if we had a line here. If we had a line here, let's see what we would. But that's the thing though. If we're thinking of two triangles, the only problem is that if we're gonna use the half base times height equation, we still need a perpendicular height. So yeah, this is not fun at all. And the funny thing is, I'm going through this paper I was reading like 2 days ago. So there isn't like a memo to like check and whatever. So anyways, let me just pause and think about this question. Okay, so I'm done thinking. So this is the conclusion that I've come to. This is just a 4-mark question, yes, but I feel like what I'm about to do would have been worth about 6 marks or so. But it feels like I have enough space. So let's do what I'm thinking right now and see where it takes us. So what I'm thinking is this point here, right? Well, it's not necessarily a random point. Well, it is for now. So it's a point. This point here, right? What I'm going to do is, remember, for this formula of our trapezium to work, we need the sum of the parallel lines, which is easy to get. But then the distance apart, right? We kind of have to finesse the question. We kind of have to do something extra. So what I'm going to do is I'm going to construct a line here. Yeah, and this feels like overkill, to be honest. Like I don't know, lie, it really does. I'm going to construct a line here, right? That will be perpendicular to EC. So this line that is perpendicular to EC, the distance of this line is definitely going to give us the distance apart of our parallel lines, because it's from this point going straight down. So getting this distance here, right, we obviously will need this coordinate. We need the x value here and the y value here. The reason why the x value and the y value here is important is because that x and y value is going to give us this distance. So it looks as though the easiest way to get the coordinate here is to get the equation of this line here, you see. So yeah, let me just write out what I'm doing here. So here, let's write here construct B, let me choose a random variable, A, B, C, D, E. Let's say construct BF perpendicular to CE. Construct BF perpendicular to CE. And then let's get the equation of BE. So the equation of BE, firstly, right, since BE is perpendicular to CE, it means that the gradient of, since BF is perpendicular to CE, it means the gradient of BF is equal to -2. Or rather, to make better sense of things, the gradient of CE multiplied by the gradient of BF should equal to -1, right? Since we said our line is perpendicular to the CE. If you put the equation, the gradient of CE in this formula, we're seeing that our gradient of BF is just going to be what you may call a -2, you see, because both sides here you would need to divide by a half. Excuse me. Yo, I was about to sneeze. I was like, bro, the mic. Anyway, so this is the gradient of BF. So the equation of BF, right? We know it's going to be y minus y1 equal to m and then x minus x1. This is for BF that we're dealing with. So for BF, we know that the line would pass through B, right? So this is an x value and a y value of BF. I mean of B. This x and y value, we're gonna put it into. We actually don't need to, because I mean, like, this y-intercept here is already a half, because the x value is a 0, y is a half. But anyways, if maybe you did not spot that on time, then you would just put in here the gradient is a half. Oh no, -2, bro. Gradient is a -2. 1x value is a 0, and then the y value here is a half. Solving here, you can have -2x. The half comes over, it's going to be a plus here. There you go. This is the equation of BF. Now you know that these points, these graphs, they meet at the line, the equation of this straight line, right, and the equation of this line, we have them, and they meet here. So we can easily get that coordinate so that we can get that distance. My suspicion is that this question was 4 marks, so that you don't like lose a lot of marks at the same time. But anyways, I mean, the memo of this paper will be released soon, and then we'll see what they did. But anyways, let's carry on here. We need to find out where these two straight lines meet, because where the two straight lines meet is the coordinate we need, right? So let's see here. So here, BF, the line BF, let's say, what do we need? What am I trying to do here? This is the let's say the YCE equal to YBF. I'm equating the two equations, right? So the two equations, this is a half x minus 7. Half x minus 7 is equal to -2x plus a half. And then work out where they meet. So here it's going to be a half x plus 2x. Here it's going to be a half plus 7. A half plus 2x is like 2.5. Half plus 7 is like, what does that give you in the calculator? It's giving you 15/2, bro. 15/2 is nice. Okay, divide both sides by 5/2. What do you get? Let's see here. 15 divided by 2 divided by 5/2. Okay, that's like a 3. That's very promising. So the x value is a 3. So the y value, you can sub it in. You can get that by subbing the 3 into any of the two equations, because I mean, they meet at this point. The x value here is a 3, and that kind of makes sense. I mean, it doesn't look very much to scale, but it is what it is. Maybe it is what it is. So let's see what the y value would have been here. This would have been like -6 plus a half. What is that y value going to be? -6 plus a half is like -11/2. negative 11 over 2. Negative 11 over 2 is roughly like negative 5.5. So this, let's see, yeah, it kind of matches because it would be before this one, but after this y value. So negative 5.5 kind of makes sense. So we have this coordinate now. So getting the distance BF, we would need the distance formula. So let's get the distance of BF using the distance formula. So rather here, let's say therefore F would be 3 and negative 11 over 2. So here the distance of BF, just make sure this is clear. Whoa. Here we go. The distance of BF would then be square root. Where is the coordinate of B? Where is B? Okay, no, let's just see. Let's just put this here. So this would be like, we say 3 negative 11 over 2. So the distance we can say is 0 minus 3. 0 minus 3 squared plus a half minus this value. So it would be a half. If you minus that value, it means you have to plus. All this, you might as well just put it into your calculator, you know. And again, as mentioned, my suspicion is this question was 4 marks so that you don't lose too many marks for one question, because this question is definitely overkill. But it's either overkill or I totally missed something. And now I'm just doing extra work for this question, which is like sad. But if it gets you the marks and you know all you're doing is mathematically correct, then just carry on, you know, just carry on and do it. So that's the distance of BF. So now that we have the distance of BF, it has given us the distance apart, you see. That's the distance apart, but we still need the sum of the parallel lines, meaning we still need the length of BA and CE. What a wow. Shoo. To be honest, as I'm looking at this question some more, I'm like, guys, 4 marks. Dogo. I don't know. I feel like this is one of those questions that we're just throwing in there to, like, you know, just stop in your tracks in terms of confidence. Because what? Like, wow, man. Wow. Yeah, it's either that or as I said, I probably totally missed something important. But it's like, hey, shame, man. Shame. Or did I miss a question? 3.2. Where's 3.2? Okay, there's 3.2. Anyways, it's fine. Let's carry on. We need the length of BA and the length of CE. So the length of BA, we can just use the distance formula. CE, we can also just use the distance formula. So let me write it up here. Let me write it here so we don't waste too much space down there. So what we're writing here is for 3.3.1, right? Is it for 3.3.1? 3.3.2. So we need AB, right? The distance of AB, we said you're gonna use the distance formula. 0 minus 5 squared, and then a half minus 3 squared. Minus 3 squared. That's AB. And then the CE distance, we'll just put them in the calculator after this. CE, it's like, this would be, remember we said this was actually supposed to be negative 10 and negative 6. So negative 10 minus 4, negative 10 minus negative 4 actually. So this would be a plus. And then here, negative, wow, I think let's just keep it. This is what I was gonna do is start with the y's, but I'm not trying to, let me try not to confuse. Oh no. Yeah, let's just, so it's easy to start with the x's, even though it doesn't matter if you start with the x values or the y values. I'm just trying to make sure that, you know, we do the same thing over and over again so we don't confuse anyone. So you see here the x values, let's see, minus 6 and then minus the 6 here, and then here minus 10 minus the negative 4. So it means you'd need 2 plus. So let's put all these in the calculator and then get those distances and then get our area of our trapezium. So this question could have easily been a 7-mark question, but yeah, maybe we missed something, or maybe I missed something. But since we're so close to the final answer, we might as well keep on going and then, you know, get the thing. So this is 5 square root of 5 over 2. Ooh, bro. The way I'm busy here wasting space. Yeah. It's very, very tragic. It's very tragic. You know, jig. So this is 5 square root of 5 over 2. The other answer for C, the answer for CE, let's see, square root of -6 minus 6 squared plus -10 plus 4 squared. That's 6 square root of 5. Whew. Yeah, ne? I don't even know how long we've spent on this question, but it's been long, man. Like, wow. I can't wait for when the memo comes out so that I can quickly check, hey, what did they even do relevant? So we have this, so we can put that into our area formula. You see, so here, our area, let me actually write it up here. I see area, let's see here, area is equal to a half. The sum of the parallel sides. Remember the parallel sides, it's AB plus CE. And the distance apart is just BF. You see. So let's put in that information and then get our answer. So let me write it down here. I see. Paste. So that being done, or rather, why do I have to put it up there? You know, let's just put it together down here. Let me bring up these two things here that I wrote up here. Let's bring it down to the bottom, because having it all the way up here is really not helping anyone, you see. So let's do this. Cut. Bring it down here so that at least the PDF will communicate with each other, you know. Paste here, make this a bit smaller, make this a bit smaller. Yeah, there we go. So putting all this into the formula, what are we gonna have? Here we're having here a half. AB is like 5 square root of 5 over 2. CE is like 6 square root of 5. Nope, there's no over 2, my bro. It's just 6 square root of 5. And then BF, what is BF? 3 square root of 5. Whew. Wow. Yeah. Overkill, overkill, overkill. But hey, we have to give people the answers, eh? 5 square root of 5 over 2 plus 6 square root of 5. And then 3 square root of 5. Wow. Yeah, to be honest, I keep thinking to myself, bro, I think you kinda overshot the runway, like literally. I do feel that way, but it's kinda late now, so this is 255.4. 244. No, 255.4 actually. 255 over 4. I keep saying 0.4, it's over 4. So this is going to be the area of the trapezium. So looking at the dimensions, like you see, this distance here was, I mean, from 0.5 to like somewhere there, that's almost a distance of like, you know, 5 units or so. This here, yeah, I think our answer is fine, you know, our answer is fine. We shall move on. It was very, 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 it's quite an interesting question, this one. So the only dangerous thing with questions like these is that you'd obviously be thinking to yourself, wow, one single error or one small mistake and the whole thing is just gone bust. But hey, gotta do what you gotta do, man. Let's see. The next question out of 2 says, if point K is the reflection of E in the y-axis. So if point K, I feel like I have to get this picture over again because this one is too cluttered now. Let me just get this picture. Why did I give myself so little space? Doggo. Let me just crop this out. Make this smaller also because we kind of need to, you know, did the does. So with our question, right, they said if K is a reflection of E in the x-axis, K is a reflection of E, no, in the y-axis. So K is a reflection of E in the y-axis. Literally what that means is, right, this is the y-axis here. If E is this on the right-hand side, K would be on this side. You see, like literally directly on the other side. Meaning if the, you see, let me actually draw it like this. Let me just draw a straight line like that. See, oh, forgot to do the magic. Zoop. There we go. So what they're trying to tell us is that if K is a reflection, if E and K are reflections of each other about the what you may call the X, what is this thing doing now? About the Y-axis, right? What that means is if, let me actually remove this thing. I think it's making things complicated for nothing. If this is E, K is right on this side here. The idea with K is that it has the exact same Y value as E, like literally. See, like from here, straight. Remember, it's a reflection about the Y-axis, you see. So the distance here is 6, meaning the distance here should also be a 6. Here the Y value is -4. Here the Y value also has to be -4. Yeah. So the coordinate here would be 6 to the left, right? Which would be -6. And then it's still at -4, right? So here this is -4. There you go. You see, that's your reflection about the y-axis. So that's the value of K. So K, the coordinate of K rather, is this and this. Perfect. 4 marks. We need to calculate the perimeter of KEC. Where is KEC? Oh, there's K. K is here, remember. K, E, and C. We need to calculate the perimeter of this. So, okay, this is quite interesting. So this is actually working for our benefit then. So this whole line here, remember, perimeter just means you have to add everything up. The length here plus the length there plus the length there. So with this kind of a question, what we know is, okay, remember C was down here, right? This was negative, I think it was also -6. Yeah, it was -6 and -10. So since K and C have the exact same X value, that's going to make our life a bit easier, because this distance here, as long as the X value at here is, as long as the X value here is a -6 and the X value down here is also a -6, it means this is a straight line going down. So for us to get the distance of KC, we just need to compare the Y values of K and C. So from -4 to -10, that's a distance of 6, you see. So KC is equal to 6 units. And then CE, we worked it out in the previous question. Let's actually just double check that what we did was correct there. Let's see, let's try it again. -6 and then -6 squared plus -10 minus what you call -4, that's going to be a plus. Then here's 6 squared root of 5. And then here, KE, the fortunate thing is the Y value here is exactly the same as the Y value there. So it's just a distance of 6 units plus 6. So it's 6 plus 6, which is 12. Therefore, the perimeter is going to be equal to 6 plus 6 square root of 5 plus 12. Okay, that's the way we like it. 6 plus 6 square root of 5 plus 12. Yo, wow. Strange looking perimeter, this one. So this is 18 plus 6 square root of 5, which is going to be equal to 31.42. 31.42, which is quite interesting, man. Maybe might as well put this in decimals as well, you know. 255 divided by 4 in decimals is like 63.75. 63 0.75 square units, or units squared. Meters, yeah, only just square units. And then here, units. Just for the vibes, you know? Even though it's not physics and you don't have to, but this just kind of shows you know what you're doing, you know? So they want us to get the size of angle KCE. Where is KCE? There's KCE. This angle here is what they want us to get. So we might as well like copy this whole thing here, you know, bring it down to our other portion. Ah, come on, bro. We were vibing nicely, my guy. Eh? We were vibing nicely. What happened? Well, let me just sort of take a screenshot or something, you know, because this sketch here is what we need to be able to, you know, work out the question that they're asking us down there, because they're asking us for that angle there. The fortunate thing is it's only like, is it a 3-mark question? Yeah, something like that. So let's just take it down there. How many marks? 3 also. Whew. Yeah, I feel like this, yeah, this paper 2 starting to throw some hands, eh? But it's fine, you know, we are holding our own in the meantime. In the meantime. So this angle is what they need, right? This whole angle here. Yeah, what can we do to get that angle? It's a 3-mark question, so we really don't want to struggle too much unnecessarily. Because like, why? We might as well just use the cosine rule. Yeah, because the cosine rule, we have all these dimensions here. Dimension, dimension, dimension. We're looking for this angle in the middle, you see? So remember with the cosine rule, if you're looking for this angle, right, you at least need the opposite side of the triangle. Because you see that triangle is like this. There is K here. Hey, yo, come on, bruh. Draw your triangles nicely. I don't even know why I brought that picture. Now it's kind of messing things up, you know. Ish. Calm down, my bro. This. Then there is this here. Then there is that. Yeah. This is what the triangle looks like. The funny thing is, this is a right angle triangle. Wow. Yeah. Because this is a straight line. And then this is a straight line going down. This is K, C, E. They want this angle here. So you can actually use normal trigonometry to get this angle, because you can actually say opposite over adjacent, or whichever variation you want actually. Because remember, this distance is 12, this distance is just 6. So if you want to use 10, you can say 10. No, let me just put 6 square root of 5 here. Let's just use one of the normal ones, you know, because if you use 10 here, people are going to be thinking of angle of inclination and all that. Let's just use opposite over hypotenuse. So sine opposite. No. Sine the angle, which is KCE. That's what the one. Yeah, KCE. KCE is got opposite over hypotenuse. There you go. Getting the angle here, you have to do shift sine the number there. So shift sine 12 over 6 square root of 5. What you're gonna get here? What you're gonna get when they come for you? Shift sine 12 over 6 square root of 5. And then what you have there? Wow. 63.43. So many 63s. This is creepy stuff, man. Creepy stuff. But that's your angle there. Nothing crazy, nothing major. I was thinking of the cosine rule. I was like, my guy. So much work. Anyways, yeah, let's move on to question number 4. Okay, question number 4 says, in the diagram, the circle centered at M. So you see, we're reading it, we're stopping, we're looking at what they say. They say this is the center, fine. T and R, where is T and R? there is t over here. There's wait. Nope, we have to be careful. T is here and r is there because they say t and r are the x-intercepts of the circle. A is a tangent. What? No, a tangent is drawn to the circle at K. So you have a tangent over here. You have a circle, two x-intercepts. I think the rest here, it was not part of the sketch. It says here, M is a point on the line y is equal to x plus 1. Okay, that's interesting. And then they say here, determine B in terms of A. So if you're going to determine B in terms of A, fortunately, remember, M is a point on the line. You see, so this is the line here where M is. So the x value of M is A. The y value of M is B. You can just throw that into this equation. And then they said you should get B in terms of A. So this is good enough. 4.1. Wait a minute. What just happened here? This is like same question twice. Come on now. This one was a 1 mark question. So the 5 mark question here wants the coordinates of M. So we'll just see if it says 2 over 3, 2 and 3. But we'll see. So the coordinates of M is basically a point that is in the center of the circle. All we have is K. And okay, well, what we do have though is the equation of the straight line. I think this is quite useful. The reason why I think this equation is useful is because firstly, whatever M is, right, we know it is A and B. Now, the first question we just answered is very useful because don't underestimate questions that ask you to do stuff like this because they're always giving you hints. Because instead of looking at A, instead of looking at M like that, we can look at M like this, coordinate A here, and then A plus 1 here. You see, because this is the X value, and then this is the Y value, or rather, this is the A value, this is the B value. The B value is just A plus 1. Since we know this is M, the other thing is the information they gave you, make use of it as best as you can. So instead of us like struggling too much, remember we want a coordinate of M. You see, so we could be thinking of things like, okay, we don't have the equation of the circle, fine. I mean, it is what it is, but we have this line. And the other thing about this line is we also have another point on that line. So this is useful for something. So you want to be creative with questions like this, because the one thing I'm already thinking of here is things like, I don't know, the gradient of a circle, whatever the gradient here, we know it's a positive 1. I mean, the gradient of a straight line here, the gradient is positive 1. And we know that these two coordinates would give us the gradient. So that's one thing I'm already thinking of, you see. We know that we can label this x1 and y1, and then we can label k x2 and y2. So this is like 5 and 7. You see, x2, y2. So this all being said, it says here y, right? No. I wanted to say that the gradient is y2 minus y1, x2 minus x1. So it's just being resourceful. You see, being resourceful means that you want to milk every single piece of information they give you before you think that they have not given you enough information. You see, so here we can know that the gradient is a 1 and y2 is a 7. Y1, we said it's a plus 1, so you want to be careful there, put that in brackets. X2 is a 5, x1 is a. So all this being done, what do we have there? We have the following. We have there 7 minus a minus 1, 5 minus a, and then this is 1. Solving for a here, we just have to, what is up?
Where did you get the a plus 1?
Okay, so the a plus 1, we got it from here. You see, we got it from here where we know that this is the equation of the straight line. Now, this straight line passes through this point. So this is an x value of the straight line. This is a y value of the straight line. So if you put y here, our y value is a b. So we just put a b there. Our x value is a. So we just put a there. So this is b in terms of a. Yeah. So the coordinate of m, instead of writing it as a and b, we just wrote it as a and then a plus b. The reason for doing that is it's easier for us to work with fewer variables. If you have two things that are different, it's harder than just having one. You see, that allows you to use one variable for different things. So all this being done, we know that we just have to take it slow. You see, here we can have the 7 minus 1 is a 6. And then here 5 minus a. This is just 1. This is, I might as well put it over 1 so that we can just cross multiply. Cross multiplying, you have 1 times that, which is like 6 minus a. 1 times that, which is 5 minus a. Oh, this is not good. I think I made a mistake. I have to double check. Because if you have two sides that look the same, there's a problem. So let me just backtrack and
Levi,
see. Yeah, bo.
like, I don't know, but if you see that, I'm not saying those two lines are perpendicular, right? Like M and the
No,
10.
they are. Yeah, they are. They definitely
So
are.
can't we like maybe use like the equation that negative, not negative x plus 1, right? The y is equals to x plus 1, right? I don't think you can sub that in. It won't give you, I don't know.
Well, whichever way, right? I'm trying to see what could be the problem here. Because, let's see, we multiplied inside negative, multiplied inside a negative. 6 minus 1 is that. Negative a is there. Let's see at the bottom here. The bottom, it's 5 minus a. And then here, so we see it here, y value is this minus this, and then this minus that. This gradient is a 1. Because I'm trying to figure out where the error could be here. This whole thing times 1, and then this whole thing here times 1. What? This doesn't make any. Oh yeah. This equation is not making any sense at all. Or rather, it's not helping. So we might as well abort ship for here. But let me see what else we can look at. To get what you may call. To get what is this thing? To get the code. What is the marker location? So the marker location is 5. So you see what I just did there. So I mean, like whichever way, wherever we are now, the marker location is a reminder of how much you should think. So, but the other thing that I'm also thinking of is, but why is this not working? Y2, we made it a 7. Y1, we made it a plus 1 because that's what our p value is. And then this and that, this and that. 7 minus 6 is 6. Okay, well, if it's not working out, I mean, we can't force it. It's almost like we kind of have to eat our own words. Oh, because I did say in the beginning that whatever we're gonna do, that we kind of have to be resourceful. So in terms of being resourceful, so as mentioned in I think what Chloe mentioned, something about lines being perpendicular. So we do know that these two lines are perpendicular. So one or the other, that has some merit to it. Whether it's gonna help us, I think so. We'll just have to see what we can do. But another thing is, let's see other pieces of information they gave us. They gave us the value of r. So there's r over here, so, and then there's m, rm. Okay, I think we could use the distance formula, because this is the radius of the circle. This is also the radius of the circle. You see, so that's another way we could try out, to get something going. So we know that mr is equal to mk. So let's just write that out. You see, mr is equal to mk. So this, let's just put a question mark because it's not working out. So the distance of mr, right? We know that, let's just get mr first, or an expression for mr. We could say there 6 minus a, but I don't know if it's really going to be helpful. Let's see. 6 minus a squared. And then here, this is going to be like 0 minus the value of b. So 0 minus a plus 1 squared. But then we have to put brackets there. Otherwise, the whole thing is going to be messed up. So give me 2 seconds. Give me 2 seconds. What is this thing here? What did I write again? A plus 1 squared. This is also a bit too big. So anyways, let's see. If we simplify this, the best we can get is, let's see, this is going to be square root of 6 times 6 is like 36, and then minus 12a, and then a squared there. Here, you'd multiply the negative inside, right? So whichever way, negative a, let me just maybe not finesse this one. Let me just do this one properly. So there's going to be a negative a here, and then a negative 1, the whole thing squared. So let's see what this is. We still have about 36 minus 12a plus a squared. To be honest, the more I'm writing this out, my brain is still thinking to myself, does it really have to be this weird? I don't think it has to be this weird. Maybe there's something simple that I'm not seeing right now. But then I mean, like, while we're working on it, we might as well just do whatever we're doing before we just stand still. So here, we know that if we expand this, this would have been like a squared, and then would have had like positive 2a, and then positive 1. If you were to fail out this bracket over here. But anyways, with all this being said, let's see how far this gets us. So in here we have 36 plus 1, which is 37. That's a very odd number to have. But hey, what can you do? What can you do? Can't complain. So for negative 12 plus 2, that's going to give us a negative 10a, and then this plus that, these two together is going to give us 2a. So this is the value of mr. Let's see the distance of mk. You see, so the distance of mk, let's see what the distance of mk is. What's that thing now? Where is mk? Let me write mk here. Mk. So mk, we can put here this here. So we can have the a minus 5 squared, a minus 5 squared, and then the b value minus 7, right? So our b value, we know it's just 8 minus 1 minus 7 squared. Simplifying this, we said if you FOIL out your brackets, right, this would be like a squared minus 10a, and then plus 25. Here, this would be 1 minus 7. What is 1 minus 7? 1 minus 7 would be like a negative 6. This would be like a squared, and then we would have the negative 12a, and then positive 36. See, let me just show what we did here. So here we would technically have had like a minus 6, right? Squared, of which a minus 6 squared is just a minus 6, and then a minus 6 again. A times a is a squared, a times negative 6 is negative 6a, this another negative 6a, this a positive 36. You see. So anyways, moving on, right? Let's see what we get. Hopefully we don't end up with the exact same thing, otherwise that's going to be like super annoying. So let's see, a squared plus another a squared, that's 2 of them, so it's like 2a squared. This minus this, that's like negative 22a, and then the 25 plus the 36. That's interesting. 25 plus 36, that's like 61. So yeah, we're dealing with very weird looking numbers here, and to be honest, yeah, it doesn't look very pretty at all. It's like yeah, ne? So anyways, we know that mk is equal to mr, right? Because they're both the radius of the circle. So here we can basically say, wait, I forgot to put a square here. This and this is squared. So here we can basically say, therefore, the square root of 37. And to be honest, as I'm writing this, you know, like sometimes the longer a question stretches out, the less confident, like, you normally feel about it. So it's like, But I'm like, sometimes you just have to do what you gotta do. So at the end here, we're gonna see what we're gonna get. I see you put 2 and 3 here. I wonder how you got 2 and 3, but I hope we're also gonna get 2 and 3, so that at least we also know we're right. Let's see.
The reason why I put the 2 and 3 there, because if you read the continuation of question, it says there if m is 2 or 3, the radius. So I think what you're doing is right, because they say the radius of the circle. So
well, let's see. Oh, yeah, okay. Well, let's see. So hopefully, yeah, anything like that definitely is telling me the answer. So let's see what we do get here, though. This is going to be 37, 10a. Yo, the only thing is the way these are laid out. It's like, yo, but let's just carry on and see what we end up with. Because if it bombs out, yo, it's just going to be a bit frustrating, you know, because that's just how it is. So with this, if you put these two at the same side, they'll just cancel each other out. And then let's just take everything with a to the left. So this is like negative 10a plus 22a. And then here the 37 over the other side, 61 minus 37. What is 61 minus 37? Giving us something normal. Oh, it's a 12. Oh my God, I mean 24. Sure, this feels so good because confidence has come back. So negative 10 there plus 22, that's like a 12. So it's like 12a, 12a. And then divide by 12, divide by 12, a is equal to 2. Very nice. Therefore, b is equal to 2 plus 1, which is a 3. Whew, relief.
perfect.
Yeah, finally. So as mentioned, as you saw, as we were going through this question, it was not like all fun and games. Like it was like, okay, this question is throwing hands, you see, and it was throwing some proper hands. But it doesn't matter. It doesn't matter. Depending on whatever you're doing, if something does not work, it does not mean you should just give up. If it doesn't work, it doesn't work. You know, I cannot think to myself, why is this not working out? But it's not. So we cannot do anything about it. But anyways, let's move on to the next question. So they gave us they said here, if the coordinates of M, well, let me just make sure here I put down the thing, fine. If the coordinates of M are this, calculate the length of the radius of the circle. So fortunately, in our case, we can already take any one of these ones here, and then we can just throw those into the what you may call. We can just throw the value of a into either mr here or the mk. I'm just gonna choose mr just for the vibes, you know. So we already know that this is mr. Just copy it, and we can just paste it here. Since it's just a 2-mark question, this is 100% legal. So the a value that we got from the previous question was 2. So this is going to be mr, which is the radius. Going to be square root of 37, 2 over there. Or this we can just put it into the calculator. So in the calculator, let's see what we're going to get as the value of mr. Square root of 37 minus 20 plus 2 times that. Whew, is a 5. So yeah, 5 is a pretty normal looking number. So we know that we are somewhat on the right track. Let's see here. What's the next thing? The next question here says they want the length of TR. Oh no, what did they length of? They just want TR, of which TR is a line. So they do want the length of TR. So from T to R, the easiest thing to do is to just get the X value of T, because you already know the Y value. The Y value is already a 0. See? So the X value is all you need. So getting the X value, we can see that it's the X intercept of the straight line. And with all the information that we have, we can easily just get the equation of our the equation of our circle. You see, we can easily get the equation of this circle and then get TR. But then before we even do that, let's just try and see what's the mark allocation. Because the mark allocation should always give you an idea of like how much thinking and how much writing should be done. But without being lazy, I mean, like it's a 2-mark question, and yeah, I mean, like it doesn't seem like it's going to be difficult. So we might as well just get those 2 marks from writing a lot. It's fine, you know, all the marks count. So the equation of our circle here, we know that the standard form is going to be a x minus a here squared, and then y minus b here squared, and then r squared. So we already know that the radius is a 5, the y value of the center is a 3, and the x value of the center is a 2. So we have everything. So in this equation, we just want to make y a 0, so we can get the value of t, which is over here. So making y a 0, it's not anything crazy. we are not going to struggle for that. So here, got to put a square there. So this is going to be x squared minus 4x plus 4.
No.
And then this, hello?
Mm.
Somebody,
Sorry.
what is up? Oh, you forgot to mute yourself. Ha ha. Okay, sorry. That was actually not funny. I don't know why I was laughing. But it is what it is. It's fine, it's fine, it's fine. It's so good, it's so good. But thanks for that actually, because it just made me think that wait, I didn't put I just jumped, you know, like why did I even do that? My brain is just too far ahead. I must calm down. So from here, if you FOIL this out, this is what you're gonna have. This is just technically -3 squared, which is like a 9, and then 25. So I think the other thing is, honestly speaking, during, like, let's say while we're going through a question, if there's a question that you want to ask, just, you can always unmute yourself and ask, like literally. You don't want to think that you can't, because you actually can, like literally, like legit. So moving on here, we're going to get 2 values of x, but let's see everything on the left. This is looking pretty weird, but oh well, -4x. So 9 plus 4 minus 25. 9 plus 4 minus 25. That's going to give you a -12. So fortunately, this can easily be factorized, because factors of 12 that give us a 4, it's, nope, it's 6 and 2. A -4, we would have to say -6 plus 2, you see. And then, what is up? What is up?
Can you kindly explain how you got the coordinates of M?
The coordinates of M. Are you referring to this question?
Yes. Okay.
Okay. Okay. Are you in the group?
Yes.
Okay, so it's fine. I'll just send you the recording to when we did 4.1.2, and then you can just go through that, because all we did to get the coordinates of M was we said that MR and MK are the same because it's the radius of the circle. So for M, what we know is that B, you can write it as A plus 1, you see. So the coordinate of M, we were looking at it as this here, you see, A and then A plus 1. And then we just used the distance formula for MR, distance formula for MK, and then we made them equal to each other. And then we got a value of A. Once we got a value of A, we just put that into this formula, and then we got a value of B. See, so the recap of that, I can always just send it on. What's that thing here? I can always send it on the group. So yeah, is that okay?
Yeah, it makes sense.
Oh, perfect. So here, solving for x would be equal to 6, or x would be equal to -2. Zoop. Which makes sense because the 6 is already here, which is the r, and then this is a -2. So clearly the distance here is just 2 units, and then 6 units, which is 8. So you may be questioning, but why so much writing for 2 marks? If you don't want to write, just don't write and lose all marks, you know. Might as well just write whatever you want to write, or just do the writing, get all the marks, even if it's just 2. It's really not a difficult question, this one, so it's okay, I guess, unless there was an easier way to do it, and there's no point just thinking of the easier way when you already know something that works, and we can just write it instead of wasting time. For 5 marks, let's see what this next question is saying here. It says determine the equation of the tangent to the circle at K. Write your answer in the form this. So we want the equation of the circle, no, the equation of the tangent to the circle. So that's a what you call a standard question that we can always expect to be asked when it comes to this kind of work. Oh, what just happened? I have to draw my own circle now. It's fine. So we have a circle, and then we also have a tangent, right? So with this circle and our tangent here, the one thing that we know is that if you're gonna be working out the equation of a tangent to a circle, the easiest thing to keep in mind is it's just an equation of a straight line. You see, so an equation of a straight line, we can get it using this equation. If we can get the gradient, and a coordinate that the line passes through. We already have a coordinate that the line passes through. It's k, 5 and 7, if I'm not mistaken. So we have that coordinate, you see. So since we already have that coordinate, I mean, we have this and this sorted. We just need a gradient. And the one place we're going to get a gradient is the one place we always get a gradient for these kinds of questions. Because these kinds of questions, it's the same thing over and over and over again. They won't be different. We have m here. It's 2 and 3. This here is always perpendicular to that because a tangent is always perpendicular to a radius. So we can get the gradient of mk and then use this formula to get the gradient of the other line here that it is perpendicular to. So in the gradient formula, we can use the coordinates m and k first. So m and k in the gradient formula, we're going to have here y2 minus y1, x2 minus x1. And then this is like 7 minus 3, right? 7 minus 3, 5 minus 2. And then what is this now? 7 minus 3 is what? 7 minus 3 is a 4. 5 minus 2 is 3. Okay, perfect. So now we know that m1 time, we say we're going to use this formula, right? I don't even know why I'm rewriting it. So here we know that therefore 4 over 3 multiplied by the second gradient, we know it's supposed to equal to -1 since they're perpendicular. So solving for m2 here, we can just divide by this in our calculator on both sides there. And then we're going to get here -3 over 4. So we have our gradient. And then we're home free. We're home free because we said that we just have to use this formula here. So in this formula, what we know is that we're going to say here y minus the y value that the straight line passes through. And then here the gradient is -3 over 5, no, -3 over 4 rather. -3 over 4. And then, hi Bowman, what is the x value here? That's just x. The x value here is the x value of the coordinate that the line passes through. And then here we are, you see, nothing too crazy because these questions, same idea all the time. So we have to solve for y here. Y is going to be equal to, let's see, this goes in there. This in there, it's going to be like a positive 15 over 4. And then the 7 would have come over to the other side here. So you just multiply it in the bracket, right? We got these two here. And then the 7 comes over there, of which we can just put this into the calculator so we can get to see what the y intercept of the line is. So let's see here, plus 7. That's like 43 over 4. It looks a bit strange, but let's see what 43 over 4 is in the calculator. 43 over 4 is like 10 point something. So let's see. Logically speaking, looking at how the Cartesian plane is set up, if this y value is a 7, right? The y-intercept here, it's telling us it's like a 10 point something. 10.75 to be exact. And that's kind of accurate, you see. So this 10 up here is like 9 point something. I mean 10 point something. So it's fine. Nothing too alarming over there. So we have the equation of other tangent, you see. So that is that. With this next question, for 2 marks, they're asking us, what do they ask? They say the horizontal line is drawn, a horizontal line rather, is drawn as a tangent to the circle M at the point N, where N, well, at the point N, right, where D is smaller than 0, write down the coordinates of N. So what I normally do is, I mean, like whatever questions you get for yourself, right? I mean, always draw yourself pictures, even if the pictures are not given, because you cannot, I mean, if we do have a picture, we are given the circle, right? But then, apart from us just being given the circle, they said a horizontal line. So remember, a horizontal line is just a straight line from left to right. This horizontal line is drawn as a tangent. So as long as it's drawn as a tangent, it means that it's either going to be up there. Let me just do this nicely. It's either going to be up here or it would be down there. But then the key thing with this question is, actually, I think we need the exact sketch here so that our question can be proper. I hope this thing does not do some funny business. Finally. So let me just crop out the sketch here so that we can better understand the question. Because fortunately, this question, the way it's laid out, I don't think it is too crazy as long as we're able to like see it. So normally the way it is that we always like solve these questions, it's literally how you always want to do it. You know, there isn't a way. I'm trying to say that the way we solve questions here is the exact same way you always want to solve them. It's not because let's say I'm like explaining that I'm doing this. No. I'm doing all that I'm doing here because that's the only way we can figure out what we need to figure out. So we have our circle. They said we have a horizontal line, meaning we would either have it up here. Let me actually make this better now. We would either have it up here or we would have it down here. You see, but then while we're thinking like this, right? If we read some more, they said we have a horizontal line is drawn as a tangent to the circle M, right? At this point. But then the moment they say where D is smaller than 0, remember D is the Y value of where point N is. Because let me just add our fallen comrade here. Our fallen comrade is joining us very soon. So what they said about N is that it's a point either up here or a point up there. Because they said here a horizontal line is drawn as a tangent to the circle at this point where D is smaller than 0. So what they mean is the Y value of our N is supposed to be smaller than 0. So automatically it rules out the one on top here. It cannot be this line here, since two lines can technically be a tangent to this circle and still be horizontal line. But only one of them now is left because, you know, we need one that has a Y value that is smaller than 0. So this would be this it would be this tangent here. Let me try and make sure it's parallel to the x-axis. So that being said, they want us to write down the coordinates of N. Writing down the coordinates of N, there's a reason why they made this a 2-mark question. They made this a 2-mark question because, remember, a circle is very basic. This is the center of the circle. The center of the circle, going straight downwards to this tangent, right? We know that this line would be perpendicular to our tangent. Now, the radius of our circle, we know it is a 5. So the Y value here is a 3, right? Remember, this coordinate is 2 and 3, right? So since this Y value is a 3, if you go 5 units downwards, you see, 3 minus 5, you're going to end up at minus 2, see. So the Y value of this N here is just going to be a minus 2. But then its X value is exactly the same as the X value of M here. Because if the X value here is a 2, and you go straight downwards, the X value is still a 2, you see. But then since you started at 3 here, if you go 5 units downwards, you're going to end up at minus 2, you see. So that's going to be the coordinate of N for 2 marks. It's just a matter of using the center and this point here. And this is where sketching the image and doodling is really going to be helpful. Because if you just keep it in your head, then it's not going to make sense. Like, think of all the thoughts that you have in your own brain. It's very difficult for you to actually see what you're trying to think, you see. So with all questions, just sketch out what you can always sketch out and answer the questions like that. But anyways, let's see. 4.4.2 says determine the equation of the circle centered at N. Okay, so we're talking about a circle that has a center N there, passing through the point T. Okay. Then they say write your answer in this format. So the fortunate thing again is you don't want to overthink it. You see, you not overthinking it is you realizing that without even worrying about the original sketch, our circle would have this as the center, and our circle would pass through T, which we know it's -2 and 0. So as long as we know that the circle passes this point and this is the center, automatically we know what the radius of this circle is going to be. You see, because whatever circle we have, we know that if this is the center and this is a point on the circle, automatically this has to be the radius, you see, because a point on the circle, the distance from that point to the center will always be the radius of the circle. So we have the radius, which we can get using the distance formula. We have the center, which we are given. That's why this is just a 3-mark question, because they know we're not gonna have to do anything too crazy. So here our distance formula here. Let's get the radius, right? Let's say here -2 minus 2. Let's see here, -2 minus 2 squared. And then here's 0 minus 2 squared. And then this is going to be -4 squared. And then here you're going to have 2 squared. -4 squared is like 16. So this is like what? 16 plus 4. That's like a 20. Square root of 20 is the radius. You see. So putting everything into your standard form, you already know that, let's see here, x minus, the x value of the center is a 2. The y value of the center is a -2, so you have to put a plus here. And then here r is square root of 20. So square root of 20 and then the whole thing squared. You can even leave it like this if you want. You don't even have to worry about cancelling the square root and the square there. You can just leave it like this. Question number 5, trigonometry. We have entered the realm of trigonometry. Okay, this is how you do trigonometry. Wait, what? Did I just say this is how you do trigonometry? Well, I mean, the trigonometry course is definitely going to teach you how to do trigonometry. Like legit. It says here in the diagram below, right? P is this point here. It is given in the Cartesian plane. So there's point P here. It's given in the Cartesian plane. And then they say the R is a point on the positive x-axis. This question looks like something from one of the previous past papers. And then it says here, R is a point on the positive x-axis such that P or R is an obtuse angle. Without using a calculator, the length of OP. Without using a calculator, get the length of OP. You can just use the distance formula and still just do it step by step and get the answer. You can even just use your calculator to double check. But let's see, OP, we're gonna have here, we can even just write out the distance formula first, just for the vibe. You see, x2 minus x1 squared, y2 minus y1 squared, y2 minus y1 squared. Zoop. Okay, what do we need now? So this is like, remember the values here is 0 and 0. So that's going to be like x1, y1, x2, y2, -7 and 4, x2, y2. There we go. Okay, so what do we need now? Well, we just need to put it into our formula. So this is like -7 minus 0, -7 minus 0 squared, 4 minus 0, 4 minus 0. I should have just used Pythagoras, like seriously, bruh. Because, well, technically this is Pythagoras, whether you like it or not, you know? Because if you look, this here just forms a right angled triangle. Now the distance here is a 7, the distance here is a 4. But it's fine. That's what we have here anyways. -7, if you square it, it becomes a plus. This 4, if you square it, it's still a plus. Anyways, this is going to be 49 plus 16. Obviously, you can use your calculator to double check what 49 plus 16 is. Like, hello. When they say don't use your calculator, they just mean show all your steps, like, or as many steps as you can, rather, without, you know, compromising the fact that you probably used the calculator somewhere. So the square root of 65 is the answer there. That's the distance of OP. They want us to get the value of 10 theta. The funny thing is, I always say, if you're seeing a sketch like this where this is theta, always look at this point here or this angle here as theta. Meaning that in your triangle, your right angle triangle, right? There's theta here, O here, P here, the angle there. This is 7, this is 4, square root of 65. If the 110 theta is just opposite over adjacent. I mean, no, opposite over adjacent. So tan theta is opposite over adjacent. That's why this is just 1 mark question. But then this here is to the left, so this is going to be a -4. You have to be careful. You have to be very careful. As distance, it's obviously, you know, positive values, yes. But then the way it is, this is a -4. But then obviously when you are going to, what is this? When you are going to use it for like lines and distances and all that, you have to make sure that you use a positive number. For 2 marks, they want you to work this out. So you working this out, the one thing you can do for yourself is to take out a negative as a common factor. And then you're going to have theta here minus 180. No. Hey, let me not complicate anything. Let's just keep things simple. I have 2 ways in which I solve questions like this. The first one I always say is swap the numbers, right? And then you can use your cast diagram. But the thing is, your cast diagram, if you're going to start with a negative, it means you have to go clockwise first. But anyways, this is 0, 90, 180, and then 270. And then back here is 360. So normally with the cast diagram, remember we go clockwise, we go anti-clockwise normally. But when you're starting with a negative, it means you should go clockwise first. And then when you plus, you go other way. So technically speaking, 180 plus theta is going to be 180 degrees. And then plus the theta, you end up in this quadrant where 10 is a positive. So here only 10 is a positive in this quadrant. So this has to be a negative cos theta. Another way you can restructure this is I usually do something like, you can either here, right? You can take out a negative. So you're gonna have negative, you can then write the 180 as a positive now, and then negative theta like that. You see, because remember, if you take out a negative, this becomes a negative, which is there. This becomes a plus, which is there. Now the idea with cos is that what we know is only with cos can you do this. As long as there's a negative here, it doesn't change anything. You can just almost disregard it. Reason being, we know that according to our reduction formula, right? If you have cos with alpha, it is the same as cos negative alpha. See, so in our example where alpha is, it's just a placeholder for where we have like 180 minus theta here. So where the 180 minus theta is here, it's technically in the position where theta would have been. You see, so if you put the way alpha would have been. So if you put 180 minus theta here, right, just like here, it means that it's just the same as that, where the negative is not there. And it's only for cos where you can do that. And then you see here, 180 minus would have been 180 degrees minus, which would land you in this quadrant where sine is a positive. So here you would still get a negative cos theta, you see. So many ways, 2 different ways to end up with a negative cos theta here. It's just a matter of using whichever one you feel is more easier. And you can always rewind to, like, you know, get a recap of what was done. So we should just get a value for negative cos theta. Negative cos theta, according to our right angle triangle, remember cos is adjacent over hypotenuse. So this is going to be what you may call negative adjacent over hypotenuse, which is like 7 over square root of 65. You see, because the cos theta here, you have that value here, and then the negative is just this negative here. And then you keep moving forward. 7 marks. Determine the general solution. Wow, did I give myself space? Yeah, I did. Anyways, for 7 marks, right, if you're going to determine the general solution here, I wonder what we're going to do for these 7 marks. The one thing I can already foresee is that we're probably going to do some factorizing, because there's cos squared here, and then there's a mixture of sine and cos. We might actually end up doing something very Special. Probably gonna have. We'll see. Let me stop talking too much and see what we can do. Since there's a mixture of sine and cos here, we have to be creative in what we're going to do here. Otherwise, we're gonna have a problem. So, yo. Well, it looks like we can firstly. It looks like here. It looks like we can take out a sine as a common factor. And here it looks like we can take out a cos as a common factor, or 3x rather, or 3 cos x. Let me just work with that first and see what we end up with. So on the left hand side, right, it looks like we can take out a sine x as a common factor. I'm just trying to break down this based on what I can see and based on what's coming to mind first. Here, if you take out a 3 cos x, let's see what happens. There's gonna be cos x here. Here, there's going to be 1. Cos 3 cos x is gone. Oh, perfect. Now the good news is we can divide by cos plus x on both sides, you see. So here, let's see here. The whole thing divided by cos x plus 1. Here also divide by cos x plus 1. From doing that, this cancels this cancels that. And then you have sine x here equal to 3 cos x. Okay, perfect. And then, since we want to end up with like one trig ratio, it's easier if you divide both sides by cos. Divide by cos here, divide by cos here. And then you're gonna have the, what are you gonna have? This cancels that, and then you're gonna have here tan x and then a 3. From here, you can get your reference angle. So your reference angle here, you're gonna say reference angle is gonna be equal to shift tan with a 3 there. Let's see what the reference angle is gonna be. Shift tan with a 3 here. That's like 71.57. Reference angle 71.57 degrees. So now that you have a reference angle, right? Remember, this is where you are working with a positive number there. So you want to work with where tan is a positive, which is the first and the third quadrant. So in the first quadrant, you're just gonna carry on from your reference angle. You see x 71.57 plus k3 plus k180. K is the element of integers. For the third quadrant, x is equal to 180 degrees plus. So it's like 180 degrees plus the reference angle plus k180. K is the element of integers. We're getting there. This plus 180, it's like 251.57 degrees. Whew, okay. Is good. Oh yeah, plus k 180. K is the element of integers. So remember, if all this is a bit going over your head, right, then this is really your indicator that you need to sign up for the online courses. Because remember, in the online courses, that's when all this work is like taught, so you can understand it better. You know, remember, going through these past papers, it should be a situation where you kind of have an idea of like what's going on. You see, so if so if you're going to be watching all this, right, yeah, you definitely want to have an idea of like, you know, some of the work, and if some of this work is a bit difficult, then you definitely want to click the link in the description and sign up for the online courses. With question 5.3, so 5.3, it's 1 out of 3 marks, but yeah, I feel like this question has something up its sleeve. But with questions like these, right, one thing that you can see even here, I put the plus and the minus highlighted, because I'm like, one way or the other, you may be thinking of the difference of 2 squares, which is okay, but the way this is set up, yeah, it doesn't look like it's really going to help much if we like do something that incorporates the difference of 2 squares. But either way, since you're proving your identity, you do want to have the left and the right side split up. You don't want to like mix it up. So this is what I would do. The left hand side, let's start. Since we have since we have sine 3x here, and I also have sine 3x on the other side, and there's some kind of link between these two sides, but we cannot like mix them and stuff. So what I'm thinking of doing is, let's see here. So this is the question, right? 1 minus this cos 3x. Let's multiply, because what I'm trying to do is, I think with this question, we're gonna have to do a scenario where we work with the left-hand side, end up somewhere, work with the right-hand side, end up at the same place. So since there's like a sine 3x at the bottom here, the only way we can get a sine 3x at the bottom here is if we do this, multiply the top and the bottom by sine 3x, right? These two multiplied by each other at the top is going to give you sine squared 3x. At the bottom here, we now have our 1 minus cos 3x multiplied by sine 3x. So if you look at what we have at the bottom here, you may be thinking to yourself, okay, is there anything we can do with the bottom? I don't know. I do not know, but it looks like we could potentially do something with the bottom, but the top part looks quite interesting. Remember, the top part, right? You want to look at the top part as what is this? You want to look at the top part here as something from the square identity. So the top part, it looks like we can rewrite it as 1 minus cos squared 3x, and I'll explain why just now. The bottom part, we still just have 1 minus cos 3x sine 3x. Let me explain what happened at the top here. At the top, we basically used the square identity. Let me actually remove this line here because we might actually end up not needing it. So according to our square identity, right, our square identity tells us that sine theta squared plus cos. So sine squared theta and cos squared theta, if you add them up, they give you a 1. But then if the cos goes to the other side, it means that you're going to have 1 minus cos squared theta. So in our example, where we see theta here, it's just being represented by 3x in this expression, you see. Where theta is here, we just have a 3x in our expression, you see. So here, we have a 3x, you see. So all we did was, we're just using this idea to say, since we have sine squared with a 3x there, it's just going to be equal to 1 minus cos squared with the 3x. That's what happened up here, you see. Square identity. Square identity. So this is helpful because at least we can factorize the top, because this is the difference of two squares that we have at the top there. It's just going to be cos 3x, 1 plus cos 3x, and then 1 minus cos 3x. The whole thing down here is going to give us 1 minus cos 3x, and then sine 3x. Perfect. So it means that this cancels that, which is going to give you 1 plus cos 3x over sine 3x, which is what the right hand side looks like, you see. Therefore, left hand side goes to right hand side. Oh wow, what a wow, very nice, very, very nice. So the difference of two squares did help us some way, somehow, eventually, but the square identity had to, you know, barge in as well. For 3 marks, it says determine the values of x in the interval 0 to 3, in the interval 0 to 60, for which the identity will be undefined. Okay, okay. Where will the identity be undefined? So in terms of where the identity will be undefined, you have to remember that you have to consider both the left hand side and the right hand side, one or the other. So with the left hand side, right, you have the sine 3x over 1 minus cos 3x. 1 minus cos 3x. So the one way that would cause this to be undefined is if the denominator was a 0. You see, if your denominator was a 0, your expression would be undefined. So here, the identity will be undefined. Let's say here, will be undefined, will be undefined, defined where the bottom is a 0. You see, this thing will be undefined where 1 minus cos 3x is equal to 0. So we have to solve for x here, you see, to get the x values that they want. Solving for x here, this is going to go over. You're going to have cos 3x. And then you can do shift cos to get the angle on its own. So here, shift cos with a 1. This will go to 3x, right? Shift cos with a 1. What do you get? Shift cos 1. You're going to get a 0. So here it's not a matter of getting a reference angle. You're just solving for x. And then here, divide both sides by 3. So this is x is a 0. Remember, 0 can be divided by anything, but you cannot divide anything by 0. See, so x is a 0 is one of our solutions. So yeah, for the right hand side, if you write out the expression on the right hand side here, it's, what is it giving us? 1 plus cos 3x, 1 plus cos 3x over sine 3x. So here we know that our expression will be undefined where the denominator is also a 0, because you see the denominator here cannot be a 0. You see, because we cannot be dividing by 0 and this thing still making sense. So it will be undefined where the denominator will be undefined where the denominator, which is the sine 3x, is equal to 0. So we have to solve this equation. So here we're going to have shift sine with the 0 there. So 3x is equal to shift sine 0. Shift sine at a 0, shift sine 0. Then we have a 0 there. And then what? So this is like a 0 here. This is 3x, right? And then we have to divide. Oh, getting the same answers. Oh, wow. What a wow, man. Well, it is what it is, you know. It is what it is. It's the same answer twice, but it's fine. It's fine. Divide by 3, divide by 3, x is equal to 0. So therefore, I feel like we don't have to write another therefore x is equal to 0. Otherwise, it's going to seem like crazy people, I see. So we just, I think even just doing one of them was okay, since they are both sides equal to each other. But I think this is the safer way to do it, you know. Let me remove this so that it doesn't look like, you know, weird. So anyways, we're going to move on to question number 6 now. Question 6, would you look at that? More trigonometry. So it's a 6-mark question to start off, which is okay. Wow. Starting with the heavy hitters, eh? For 6 marks, what did they say here? They said, without using a calculator, simplify the following expression to a single trigonometric term. Okay, this is okay. Without you, so since you see there are numbers here, right? Don't worry about the numbers too much, especially if they are small. But then the 440 there, I mean, like the rule of thumb is any number that is bigger than 360, always just remove 360 from it and then work with whatever is left, you see. So 440 minus 360, that's 80. You know, you just take it off immediately. So this is going to be, oh, let's do it slowly. This we can write it as 360 plus 80, you know, because of the reduction formula. And then here, 360 minus, if you think of the cast diagram, CAST, the cast 360 minus, right, is practically 360 degrees, and you minus your reference angle. You're going to end up in this quadrant where cos is a positive. So here, let's just even remove this thing here, you know, negative 10 theta. That's what the 10 360 minus is going to be. See, so 10 360 minus theta is equal to minus 10 theta. Moving on. Here, remember it's this thing here multiplied by sine 2 theta. This automatically has to change to 2 sine theta cos theta, because this is a double angle and there's only one thing you can change it to. So unlike cos, where you kind of have to like sometimes wait to see which one is best to change to, with this double angle of sine, you can just change it immediately. You see. And again, shameless plug, everything we're talking about here in terms of you learning how to make use of all that we're referring to here, you definitely do want to check out the link in the description for the online courses on our course platform, #BrightYoungBrains. But anyway, so let's see, with all this being done, right, the one thing you can also keep in mind for yourself is that as long as this is a fraction, it's better off, you're better putting this as a fraction also, but then not yet maybe, because 10 is also going to change at some point. So let me take things slow, you know, because I seem to be just going all over the place. But let's see what the next step is. Here with these numbers, you don't want to worry too much about them yet, you know. So let's see here, sine 10. Here you're going to have here cos 80, cos 360 plus. 360 plus, everything is a positive in the first quadrant. And then the 10, you want to change it to sine over cos. You see sine theta over cos theta. And then here, this is still fine, 2 sine theta cos theta, the whole thing over 1. Because as long as you have a fraction here, it's best you also have a fraction there. I mean, you also have a fraction there, so everything must be, you know, working together. So this minus here is important because it's saying this is one thing, you must work on it, and then this is another thing. So the sine 10 here, still nothing for now. The 80, just leave it for now. Here though, at the top, if you look nicely, let me not skip any steps. You see sine theta times that sine theta there. It's going to give you sine squared theta. And then at the bottom, cos times the 1 here gives you a cos bottom there. And then fortunately, if you check on this right hand side here, you see this cancels that. And then here you're going to have sine 10. Before I write sine 10 again, fortunately a 10 and the 80, they give you a 90, you know, so that's not a coincidence. So what you can do is you can write this in terms of 90, right? So sine, this is technically 90 minus 80, still going to give you a 10, right? Then at the bottom here, cos 80. Here you have your 2 sine squared theta over 1. And then here, remember, if you're dealing with the 90, that is the only time where your trig ratios change. So 100, so 90 minus, right? It's 90 degrees. So this is 0, 90, 180, 270 slash 360. Ooh, I ran out of space. But anyway, so 90 minus would be in the first quadrant, right? Where everything is a positive. But then we said anytime you're dealing with a 90, that's the only time where you go from a sine ratio to a cos ratio. And then this 80 here is there. So the top part, it just sine 90 minus 1, sine 90 minus 80 is just cos 80. Here we still can just leave it the way it is, not just for the vibes. Then these cancel each other out. And then you have minus 2 sine squared theta, which is what they wanted. They said we should leave your answer as a single trigonometric term. So there's a single trig ratio here, which is perfect. 6 marks. Okay, that was good. 3 more marks. They said, given this expression, calculate the value of k if this plus this is k cos 2x. So the fortunate thing is, with the expression that were given originally, we could be thinking of, you know, compound angles, because yeah, compound angles make the world go round. These are of 3, so we don't want to think too much actually. So getting a value of k here is going to be quite interesting. But let's see what we can do. Because if we do double angles here and we do double angles there, I think we may come up with something. Let's just do it. So this is where your formula sheet has to come in handy, you see. So let's see here. Sine 60 plus something, you know, according to your compound angles, you can write it as sine 60 cos 2x, and then if it's a plus, this will be a plus cos 60 sine 2x. And then plus, I'll actually make this a bit smaller so that I don't run out of space. Zing, zing. So this is plus sine 60 again, cos 2x, and then minus cos 60 and sine 2x. Whew, that is the way we like it. So this is equal to k something something something. Wow. Let me see if I can straighten this out. Make it a bit smaller also. Push it a bit to the left. Are you able to straighten yourself out? Ooh, wow, man, fancy. Oh my goodness. Oh yeah. So all this, right? We know it is equal to the k cos 2x. So you don't want to mix up these sides. You just want to, you know, be strategic about it. So the fortunate thing is, remember, here, if you look at it nicely, it's 3 terms technically. 1, 2, 3, and 4. So let's see which ones are like terms. You see, this can cancel this because you see cos 60 sine 2x, cos 60 sine 2x. If you look nicely, this is giving you 2 of the exact same thing. So this thing here plus this thing here, you have 2 of those. You see, 2 sine 60 cos 2x. Then you have equal to k cos 2x. Now, logically speaking, you see, you can divide both sides by cos 2x. Divide here by cos 2x, cos 2x. This goes away. Your k is 2 sine 60. So to be honest, from what I'm seeing here, it looks as though sometimes the mark allocation, yeah, it does give you an idea of how much you should think. But sometimes, even if it's a low mark, we sometimes tend to not want to do certain things that make us write a lot, which clearly, according to this paper, is not a very good idea. If you know that you have something in your mind that is going to give you the answer and the answer is going to be correct, just do it regardless of the mark allocation, because sometimes you may be thinking there you need a shorter method or whatever, but no, this writing out something long is not a bad idea. So just do it when necessary. So here we can just use our special triangles, because our 30-60 triangle can help us here. 30-60, right? So here 30 is going to be 1 over 2. That's a half. 1, 2 square root of 3 here. So 60 is sine 60, right, is opposite over hypotenuse. So it's like opposite over hypotenuse. And then here, this is technically over 1. You see the k, the 2 and the 1 here. I mean, if you put this, let's just do it manually. 2 square root of 3 over 2. And the 2's cancel each other out. K is square root of 3. Fantastic, man. We love to see it. We love to see it. Question 3, I mean 6.2.2 for 3 marks. Again, it says if cos x is equal to square root of t. Without using a calculator, determine the value of this expression down here in terms of t. Okay. Well, whichever way, what that means is, well, okay, this is from the previous question, so we should not take this for granted here. This whole sine 60 plus 2x, blah, blah, blah. This is from the previous expression. In the previous expression, what we clearly saw was that this was equal to K2, was equal to K cos 2x. So technically what we're seeing here in these red brackets here, we can just rewrite it according to what we have in the previous question. So this here in our red brackets, we can put here K cos 2x. And then what we also know is K was square root of 3. Did you get K square root of 3? Yeah. K was square root of 3. So our question, we can practically rewrite it like this. You know, what is 1060? We can just use our special triangles. Special triangles. So this is 30, 60. No. Sine 60 is opposite over hypotenuse. So 1, 2 square root of 3. And then, so 1060 is like adjacent over hypotenuse. Adjacent over hypotenuse. Square root of 3, can put it over 1 here. So let's just write this over 1, the whole thing here. Square root of 3 cos 2x over 1. So the one thing that's in my mind is, before even worrying about the whole t and everything, I'm just breaking this down according to what information we have. You see. So here the top multiplied by itself, it's going to be like this, square root of, yeah, it's going to be square root of 3 cos 2x. The bottom 2 times 1 is just a 2. If you want to break it down further, which is clearly necessary since we need to end up with like a cos x, the one thing you can do here is to break this up using double angles. So since we should end up with the cos somewhere, this you can change it to 2 cos squared x minus 1. That's our double angle on our formula sheet. And this is over 2. This is cos x squared, you see. So we know that they told us that cos x is equal to square root of t. So this is going to be square root of 3, 2 here. Where we see cos x, we can throw in there square root of t, and then it's squared there. And then here we have the rest of our question, minus 1, the whole thing over 2, you see. If you want to simplify some more, you can, because if you multiply inside here, this times, so obviously the square root here cancels these two cancel each other out, and then you technically have square root of 3, 2t minus 1 over 2. Multiplying inside, I don't think it's going to make any difference. So it looks like this is in its simplest form. The question just said you should write this expression in terms of t. What that means is everything else should not be there, or rather everything else should just be a number. And the only thing that should not, there should be no variables in our expression except for t. So having x anywhere was not going to help. So yeah, this is a 3-mark question, not too bad at all. It was pretty interesting. My brain feels like it's just flowing, eh? It's good, eh? So anyways, let's do question 7. Question 7. Happy question 7. Okay, so question 7 is quite interesting. Wait, what? I am saying it's quite interesting, but I haven't even looked at it. Like, what a wow, bruh. Did I just lie? Or did my brain just say something on autopilot? Because I usually always say something like that. Anyways, this question 7 says the following, right? It says there, in the diagram below, the graphs of f of x is half cos x. So where's f of x? F of x is this one here. The amplitude is a half, perfect, because the number here gives you the amplitude. And this graph was not moved up or down, it was not moved from left to right, so it's behaving like a normal cos graph, you know. At 90, it's cutting the x-axis, and then at 270, it was going to cut the at 270 somewhere, it would have cut the x-axis again. And here at negative 90, perfect. Then this is a normal sine graph, but this sine graph has been moved 30 degrees to the right, you see. So this one is a horizontal shift 30 degrees right. Okay, so with us knowing that, right, they said here, these two graphs are drawn for the interval -90 to +240. And then they said A and B are the y-intercept. So there's A here, B there. A and B are the y-intercepts of F and G respectively. Okay, sounds good. So for 2 marks, easy 2 marks, actually, they're asking us for the length of AB. The funny thing with getting the length of AB is you may be thinking to yourself, okay, what is the, I mean, A, we know it's definitely, we definitely know what A is. The X is 0, the Y is a half. So we don't have to guess with A. B, I mean, we also don't have to guess, you see. B, X is 0, and this is just -1/2. You see. So the distance of AB is just 1 unit. Equals 1 unit. So you can even do a mini calculation if you want to see. OA plus OB is equal to AB. And then here, you know, it's like half a unit, 2 half units is going to give you a 1. See, it's funny how I wrote it like this. I should have written it the other way around, you see. Just write it the other way around, you see, because it's more normal. AB is a 1. So that being said, you can see how you can make use of your sketch. Don't think it's not to scale. It's only not to scale if they tell you. Otherwise, it's to scale. So 2 marks here. Write down the range of this. So you have to remember that your graph has new amplitude. So where is f of x? So this is the graph of f, right? So the 3 is not going to be the new amplitude. The 3 is going to result in you having a new amplitude. Or let me word this differently. Let's change. The 3 here is going to change the amplitude. The 2 is a vertical shift, meaning it's going to be, the graph is going to be moved 2 units upwards. So the graph of f, right? Let's just draw what this image would look like so that we can better give the range. So how many marks are they offering for the range? They're offering 2 marks. So you can see with a question like this one, this is the kind of a question where your theory needs to be intact. Otherwise, yeah, it's gonna be a problem. And then as I'm going more and more through this paper, yeah, I don't wanna lie to you, nah. Yeah, the paper 2, yeah, is a bit, it's at a slightly higher level than paper 1. The paper 1 for this 2022 paper, because I went through the 2022 paper and I'm in paper 1. It was okay. This one is still okay, but yeah, this one is throwing hands. It's like throwing some proper hands. So anyways, we want to draw what this graph would look like. So remember, if f of x, right, is originally, remember f of x, they told us it is a half. Is it half cos x? Yeah. So if this is half cos x, it means that this equation here, where f of x has been multiplied by 3 and you added 2. So 3f of x plus 2. Remember, all it means is where you see this f of x symbol, you just have to drop a half cos x in there. So this is equal to 3. Where you see f of x there, you're going to drop the half cos x, close bracket, and then the plus 2 there. This is your new equation. So this equation, if you multiply inside here, you can see it's 3/2 cos x plus 2. That's your new equation. So this being your new equation, we need to be able to recognize what that range would look like. You see, we need to know what the range of a graph like this would look like, because if you don't know what the range would look like, then you is not going to have a good time, eh? But anyways, let's see. So let me do this. There we go. So in terms of the range, this is saying that a standard cost graph, right? It was firstly moved 2 units upwards. So if it's moved 2 units upwards, it would be starting somewhere at I need to yeah, it would be starting somewhere at a 3 here, and then the amplitude is 3/2. So if the amplitude is 3/2, remember, amplitude has a formula. Let me try and make life easy for you. Amplitude is equal to the highest y value. Let me write this somewhere somewhere where we can. Let me actually remove this image because we don't even need it, I think. Well, I know we don't. So here the amplitude, right, is now 3/2. So the formula for amplitude, right, is this. Amplitude is equal to the maximum y minus the minimum y, the whole thing over 2. Remember, the lowest y value and the lowest y value and the highest y value give you your range, you see, because here, originally speaking, the range of G, for example, is, you see the lowest y value here is a -1. The highest y value there is a +1. So originally the range of G, right, is like from 1 to -1. Y is element of 1 until -1. That's, for example, the range of G. The original range of F, it's all based on the highest y value, which is 1/2, and the lowest y value, which is -1/2. You see. So what we're saying is this graph of ours, right? A standard cost graph would have been moved 2 units upwards. So normally speaking, right, a standard cost graph starts at 1, it goes down like this, and then it does its thing over and over again. This is what a standard cost graph looks like. This graph here is just y is equal to cos x. So the issue is, if this graph was moved 2 units upwards, it would look something like this. If this graph was moved 2 units upwards, right, it would be starting somewhere at 3, right, and then you would go something like that from 3 until like +1. This is what your graph would look like if the equation was y is equal to cos x plus 2. This is what the graph would look like. Or let me write this a bit better. Y is equal to cos x plus 2. This is just to say a standard cost graph, if it's moved 2 units upwards, it's going to go from 3 to 1. Okay. However, instead of just starting at 3, right, and dropping down to like +1 and then going back up and all that, this graph has a new amplitude. The new amplitude here is 3/2. So with our new graph, what we do know is it's going to start at 3, yes, right? And then let's draw our x-axis somewhere down here. Our graph is going to start at 3, right? Perfect. So the only thing we need to know for now is that this is the maximum y value. This here is the highest y value. The lowest y value that it goes to, we can work that out using this formula. You see, because as long as we have the highest y value, fine, and as long as we can get the lowest y value, we'll have the range, because the range is always the highest y value and the lowest y value. You see, highest y value, lowest y value. So in other words, the range here is just y is an element of -1 until +1. Here, the range is just y is an element of +1 until +3. You see, it's all about the highest y value and the lowest y value. So in our case, because this graph has been moved 2 units upwards, a standard cost graph, we already know that it will start at +3. Now, knowing that it would start at +3, it gives us the idea of the highest y value. We need to work out the lowest y value. So to do that, we can use this formula, right? Amplitude is just 3/2. The highest y value, we know it's a 3 there. The lowest y value, that's what we're looking for. And then divided by 2. So working out the lowest y value here, it doesn't look like it's too difficult. So we can times by 2 here, times by 2 here. This is just going to be 6 is equal to y minus this. And then let's maybe use a red there. If you take this to the other side, the lowest y value is equal to 3 minus 6, right? So what is 3 minus 6? Yo. Dogo. Feel like I messed up here. This goes to the other side. This comes, no. This is a 3, bruh. Oops. Yeah, this times 2 is a 3. So here, this goes to the right side, this 3 goes to the other side. So 3 minus 3 is a 0, you see. So the lowest y value is the highest y value is a 3, the lowest y value is a 0. So your graph would essentially look like this, you see. This is our graph of 3 f of x plus 2. So the range would just be y is an element of 0 until +3. Woo-hoo-hoo-hoo-hoo-hoo. Yeah, ne? Mathematics. So you can see here, this is, I mean, it's not necessarily a shameless plug, because this is me highlighting the fact that if all this kind of work, right, is like still vexing you a little bit, then you need to sign up for the online courses. Like, you really do. Because also, as long as you're signed up for the online courses, we will always be able to see, okay, who's enrolled onto the online courses. And then you'll always have access to being able to ask questions directly and all that. So you can be helped, you see. And you can always just hit me up on IG as well. Then I can always, you can always let me know what's up. So with question 7.3, as you can see, I've done what I could and it was not working. But we are here to redeem ourselves. Anyway, so with this kind of a question, right, 7.3, the one thing you definitely want to do when it comes to questions like 7.3 is, funny enough, right, in as much as what they may be asking you to do may seem very blunt, you might as well just do that. Otherwise, you may just end up going in circles trying to figure out something that's like right in your face. So anyways, this is the idea with 7.3. The key word here is they said read off the graph. You see, or read off the graphs rather. Meaning you just have to look and make a conclusion and stick with it. But you can also just make your conclusion based on, some proven assumptions. But anyway, this is a read off from the graphs a value of x for which g of x minus f of x is equal to square root of 3/2. So this is referring to a distance between the y value of g and of f. You see, you need to get the distance between the y value of g and the y value of f. So keeping that in mind, right, if you're going to get the distance between the y value of g and the y value of f, and that this is asking you want to work out which specific x value in this graph will the distance between f and g be equal to square root of 3/2. So the one thing you definitely want to do for yourself is, in your calculator, You just want to get an idea of what square root of 3 over 2 is. So let's put in the calculator square root of 3 over 2. In our calculator, that's roughly equal to 0.866. Okay, so that's a number just below 1, right? So in our case, when you're going to pick out this x value where this distance is like square root of 3 over 2, that specific x value, we know that we have to choose a portion where where g is on top and f is at the bottom, meaning the y value of g has to be above the y value of f. So in our sketch, the only scenario where the y values of g are above the y values of f is right over here. You see these y values here. These are the y values where the y values of g are above the y values of f. So we want a distance that is just below 1. So if you look nicely, logically speaking, I mean, like from here to here, the distance here is like 1. And then logically speaking, from here until here, the distance is above 1, you see. So you can see here, everywhere towards the right-hand side, right? I mean, like the distance between f and g, it's clearly going to be below 1, you see. So here, we know that the distance here is below 1. Like all these distances between f and g, they are technically lower than 1. But then in terms of you making a clear distinction of a specific x value here, that is going to result in you having 0.86, or what is it, 0.866. You picking out a random x value here, that's gonna give you a distance of 0.866. Yeah, it's clearly not gonna happen. And then from here, this is roughly a distance of 1. As you move to the left, you see the distances between the two graphs is definitely higher than 1, because this y value here is a positive 1. Down here, it's clearly below the x-axis, so this is bigger than 1. So between this point here until here, you can see the values start to decrease now. You see they're getting lower and lower and lower and lower and lower. So these the distances between our graphs here, we can clearly see they are somewhere close to 1. So just below 1, this is a good estimate, you know, an x value of 90. An x value of 90, this by observation, you can see that this would roughly be the distance 0.866, which is we know that 0.866 is approximately equal to square root of 3 over 2, right? So now that we have chosen 90 as our answer for this question, just by reading it off the graph, I mean, like, to confirm, you can just check in your calculator. In your calculator, in the equation of, put this in your calculator, you see. In your calculator, put there, you know that this is, the equation of g is just sine x minus 30. The equation of f, you know, it's just half cos x. So in your calculator where x is, you just want to put a 90 there just to confirm your answer. Let's put the 90 minus 30, I mean sine 90 minus 30 minus half, and then 90 minus 30. Yeah. Whoa. No. It's cos x, but cos x is cos 30 in this case. Since we, no, cos 90, sorry. Since we said we're choosing an x value of 90, yeah, it works out, you see. So if you put 90, if you're to test it out, right, let's say test in calculator, you don't have to put this on the answer sheet, you know, we're just doing it now so that you can know that you can always choose your answer and then test it out. You see, in the calculator, this would be 90 minus 30, and then here 90 as x as y. See, this is equal to square root of 3 over 2. So you know it works out, you see. And then that will be that. Let's move on. 7.442 marks says, for which values of x in the interval negative 90 to 240 will this expression be bigger than 0? So without, like, you know, overthinking anything, this is just saying, where will this y value multiplied by this y value, where would that expression be bigger than 0? So this expression will only be bigger than 0, or rather this expression will be a positive value if you are multiplying two things that are negative, or if you're multiplying two things that are both positive, you see. So we basically need to look for y values of f that are positive multiplied by y values of g that are also positive, or y values of f that are negative multiplied by y values of g that are also negative. But then this is without, let me just back up a bit. Let me backtrack and explain better. So we say two things, right? They're asking us, where is f of x multiplied by g of x going to be a positive number? It's going to be a positive number if you're multiplying a negative y value of f multiplied by a negative y value of g, or if you're multiplying by a positive y value of f multiplied by a positive y value of g. These are the only scenarios where the expression here is bigger than 0. So to answer this question, you need your sketch. In your sketch, what you need to do is you need to look out for cases where both graphs have positive y values and where both graphs have negative y values. Those are the cases where that you need to look out for this question. But once we have the sketch here, it's going to be much easier to explain, and you'll see why just now. So looking at our sketch, right? If you look at the sketch nicely, let's look at cases where our graphs of, let's put it this way. With our graph of g, right? This is our graph of g. This red part is where it has positive y values. Our graph of f, this red part is where it has positive y values. You see, and then let's use blue for where they have negative y values. So for negative y values, it's here. This is where our graph of g has negative y values, and it has negative y values here also. Our graph of f has negative y values over here. You see, so according to our question, we want instances where they both have negative y values and where they both have positive y values. So cases where they both have positive y values, we can see it's basically this space here. This is where they both have positive y values, because the graph of g, whether we're looking at the graph of g or the graph of f, in this space here, both the graphs of g and both the graph of g and the graph of f have positive y values, right? And then furthermore, this portion here, this is the portion where both graphs also have negative y values. So in terms of the portions that qualify for our answers, it's from 30 to 90 and from 210 until 240. Those are the portions that qualify for our answers, you see. So in terms of giving our answers, remember, this is saying where is it bigger than 0, not where is it bigger than or equal to 0. So where is our expression bigger than 0 here? It's our expressions are bigger than 0 where x is an element of 30 until 90, or where x is an element of 210 until 240. You see, we're excluding the 90 and the 30, and here we're excluding the 210 and the 240, because specifically at these x values, right, something is equal to 0. You see, this y value is equal to 0, this y value is equal to 0. So if you were to multiply something by 0, you would not be getting an expression that is bigger than 0. So that's why we have to say anything just from 30 to 90 without including the 30 and the 90, anything from 210 to 240, but without including the 210 and the 240. Whew, so that's your answers for 2 marks there. Very, very nice. So moving on, right, they said for 2 marks, they want us to work out where, this is quite interesting, right? They're talking about the gradient of g. But then now, gradient of G, why are they talking about gradient now? Well, whichever way, if they're talking about equation like this one, right? You need to keep in mind that if you look at your sketch, let me get the sketch here, copy, let me paste it down here, paste. So with this sketch, the big idea here is this symbol here. Now this symbol, we know that it refers to the first derivative, but you don't have to differentiate because you see it's trigonometry and we're dealing with grade 12 work here. So it's not within your syllabus for you to differentiate a trig graph. So when you're thinking of an expression like this one, you need to be strategic, meaning you need to make use of how your sketch is laid out. So the way your sketch is laid out, if we're specifically looking at the graph of G, right? If you look at the graph of G, since this is talking about, gradient and all that, what you want to remember is portions of your sketch where your gradient changes, right? It's at turning points specifically. So what I mean is, firstly, in terms of if you want to find out what is the gradient at specific points, just think to yourself in something like this. If you think of this line here, right, or this curve, which is the graph of G, the portion where you will be like going down, you see, those are portions where you have a negative gradient. The portions where you'll be like going upwards, you see, those are portions where you have a positive gradient. So this whole portion here, you know that your gradient is bigger than 0. This portion here where you're going down, you know that your gradient is smaller than 0. And then again here, you see you're going to be going down, 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 down. That portion, you know that your gradient is also smaller than 0. Fine. So since we now know which portions have positive gradients and which portions have negative gradients, when you're looking at this question is just talking about your graph being moved 5 units to the right. So this is here. Let's just say here, graph moved 5 units right, or rather 5 degrees right. Let's be more specific. 5 degrees right. So if this image is moved 5 degrees to the right, answering our question is not going to be difficult, because firstly, before we even worry about the graph being moved 5 degrees to the right, we can just look. So this question is asking us, where is our gradient bigger than 0, right? We know that originally our gradient is bigger than 0 from -60 until positive 120. This is the portion where our gradient is bigger than 0. So if you move the graph 5 degrees to the right, it means that this moved 5 degrees to the right becomes 125 degrees. This moved 5 degrees to the right becomes -55 degrees. You see, so that's where the 2 marks for this question come from. They basically come from you being able to, utilize the information that we're given there. It basically comes from you being able to work with the information that you are given. So your answer here, right, you're going to have to say here, x element of -55 and until positive 125, like that. Because just like this question, for which values of x will this all be happening? So this is quite an interesting question. And yeah, this is portion of the questions where this question paper was, yeah, man, it was doing its thing, it was doing its thing. So this is 7.4.2. So we're gonna move on to the next question now. So question number 8, right? We would not want to overthink anything. So the one thing with question number 8 is just the way it looks. It looks like the sketch is a bit, weird and all that. But then it's a normal regular 3D image. It says here, figure 1 shows a ramp leading to the entrance of a building. You see, B, C, and D lie on the same horizontal plane. So they mean that B, C, and D, they're on the ground. You see, they're on the flat ground there. And then they said here, the perpendicular height AC is 0.5 meters, and the angle of inclination from B to A is 15 degrees. Okay, so the ramp has an inclination of like 15 degrees. So if you want to look at it nicely, right, technically speaking, what we know is at the back of this ramp, right, you would have something like this there, you know, then here we know that this would stretch out going to where D is, you know. So just to emphasize that it's a 3D image, but we're not going to write that there. I think the only thing with this sketch is these lines here, the line EB, and the line FB. These are just lines on the ramp, you see. They're not lines that are like giving us different dimensions or something like that, you see. So that's why here in the front, they're just telling us that there's just a random line here, and then it's just a random line here. It doesn't mean that like this is like somewhere inside or whatever. No, this is all a flat surface here, and then this is just the side, you see. So the other side of your ramp would be something like this, right, where you have the bottom somewhere down there, and then this would be going all the way to D somewhere there. So whatever right angle triangle you have on this side here, you'd have it on the other side, on the right side there. And then at the back, you know, technically this would be like a whatever shape that is, maybe a rectangle or whatever. So keeping all this in mind, right, let me just also make sure that we add whoever this is, just for the vibe, I guess, Risoko. Wait, are there any questions? Nope. So with this being said, let's, what else they told us that the entrance to the building AE, so this is the entrance to the building. So you'd be walking up to the entrance, you see. They say the entrance to the building is 0.915 meters wide. Okay, walking in meters. For 2 marks, they want us to get the length of AB. So fortunately, AB is quite straightforward, because remember, as long as you're working, as long as you're being asked for a line, you have to just ask yourself, where is that line? Is it in which triangle? Stuff like that, you see. So it's in this triangle, right? ACB. That's where the line AB is, or rather, that's the easiest triangle to work with, actually. So let me draw this here.
Can you use like a trig ratio?
Yes, you can, because this is a right angle triangle. Remember, with a right angle triangle, you can use SOHCAHTOA, sine, cos, or tan, to like work out whatever it is that you need to work out, you see. So this here is like A, this is C, and then this is B. And then we know that this angle here is just 15 degrees. And then here, this distance is like 0.5 meters. Okay, so all this being said, clearly AB is straightforward. We just have an opposite side here, and AB is the hypotenuse. So opposite over hypotenuse, that's clearly sine. So sine 15, we know it's equal to opposite, and then over hypotenuse, which is AB. So let me do this here, 0.5, and then AB. All this being done, we now know that, okay, fine, we can just solve for A by, we can actually just put this over 1, and then we can just cross multiply. So we'll have AB here, sine 15, and then we'll have here 0.5. Divide both sides by sine 15. You're going to have AB is equal to 0.5 over sine 15. And remember, these kinds of questions, they didn't say anything about not using your calculator. So you are 120% welcome to use your calculator. So we have here 0.5 divided by sine 15, see, of which the answer there is just 1.93, which makes sense because at least it's similar to some of the other answers that we have on the sketch there, you see. So that's not too bad for AB. The next one here is saying figure 2, which figure? This second image here, it's showing the top view, right? It says there, figure 2 shows the top view of the ramp. The area of the top of the ramp is divided into 3 triangles, you see. So they just cut it, they just basically drew this line so that you have these lines here, so that you have one triangle, another triangle, and another triangle. So let me just do this lemma. So with these 3 triangles, right, triangle 1, 2, and 3, they said here the area of the top of the ramp is divided into 3 triangles as shown in the diagram. If BEA is 120 degrees, calculate BE. Well, let's see what BEA is. So they said BEA, which is the angle here. This angle here, they told us it is 100. What, really? No, I think I'm wrong. They said BAE. Oh yeah, of course, that can't be 120. It's an acute angle. So this is 120, right? They want us to get the length of BE for 3 marks. So 3 marks is not very hectic. We just got AB now, right? Which is like 1.93. So we have a side here and another side there, and the angle in the middle is given. So this is the opposite side. So we're clearly going to use the cosine rule here. You know, nothing crazy with this question. We're clearly going to use the cosine rule, because the cosine rule wants us to have the side on its own here is equal to AB squared. It's what the other side is. So it's AB squared and then AE squared. AE squared minus 2 multiplied by AB and AE. And then we have cos the angle, which is opposite this, which is angle BAE. We just have to put all our values in this equation, right? So BE is what we're looking for, right? AB, we got it to be 1.93. So let me just do this here. Is it 9.3? Yep. And then the AE there, they gave it to us in the sketch, I think. Did they? Yeah, they did. It's 0.915. Okay, which is fine. So I forgot to square it. 0.915 squared. And then we have 1.93, 0.9 that, and then this is the angle here, right, is 120 degrees. So with that being said, I think we can square root both sides, right? So BE here, if you square root this side, right, and you square root this side, I think might as well just do everything all at the same time, because why not? Let's put all that in the calculator, see what we get. Square root of 1.93 squared plus 0.915 squared minus 2 times 193, 0.915 cos 120. Perfect. So it's giving us 2.52, which makes sense, you know, 2.52, because remember these numbers are 52, 52, did I write 50? Yeah, I wrote 52. Just put that dimension there, or the unit rather. So yeah, 2.52 kind of makes sense because this is quite a pretty long line, as we can see compared to the others. So far so good with this question, nothing crazy. 3 more marks says calculate the area of calculate the area of triangle BFD if angle BFD is 75, and then these are equal, and then they've given us something to work with. This is pretty useful. They say BF is 5/7 BE. So where is BF? They said BF is 5/7 B what? 5/7 BE. Yeah, BF is 5/7 BE. So we already have the length of BE. So one way or the other, we also technically have the length of BF. Because if you throw the length of BE there, that value times this gives you the length of BF. And then BF, we can see here, it's the same as FE. So we have 2 lengths here. Fine. What is the question asking us? They're asking for the area of BFD. Where is BFD? BFD. Okay, so if we're going to work out the area of this triangle here, it's not going to be a hassle at all. Reason being, we can use the area rule. The reason we can use the area rule is because the way our triangle is set up, right? We know that the angle in the middle here is 75, which is fine. And then here, this is 5/7 times 2.52. And then here, 5/7 times 2.52, because this is the length of BE, right? So they say BF. Remember, there's F here, there's B here, and I think there is D at the bottom there. So we have these with these dimensions, right? we know that we don't have to struggle because they told us that these are equal, and they told us that the length of BF is just 5/7 of BE, and we have BE, you see. So in the area rule, remember we know it's area will always be a half multiplied by one side, which is like BF, multiplied by the other side, which is like FB, and then sine the angle in the middle, which is like BFD there. All this being done, BF is, what is BF? BF, we don't know what it is, but you can just put it like that in the calculator. You know, it's gonna be a lot of writing, but meh, you know, it is what it is. Gotta do what you gotta do. So this is actually the exact same thing, right? So you can actually just square it here, and then this is like sine B. You don't have to write it exactly like this, but I'm just doing it because we know it's the exact same thing anyways. So we can just put it like this in the calculator. Or rather, wait, I forgot to put 75 here. 75. All this in the calculator, we have there a half. And then fraction button is like 5/7 there. And then, what's going on now? Oh, wait, half. Fraction button 5/7. And then this is like 2.52. The whole thing squared, and then sine 75. Close bracket. Okay, we're getting an answer that looks pretty strange, but it is what it is. You know, we haven't done anything wrong. So this is what we're getting. The answer we're getting here is, let me see what this answer is here. Give me 2 seconds, I'm just double checking what I put into the calculator here so that I make sure that we didn't do anything crazy. Okay, it's all fine. So it's 1.56 meters squared. 1.56 meters squared. Question number 9, here we are. Question number 9, here we are. Okay, let's see what we can do here. What should we do? It says in the diagram, D, E, F, G. Where's D, E, F, G now? There's D here, E, F, G here. It's a cyclic quad, so obviously that's some useful information. It means that we have opposite angles adding up to 180. We have an exterior angle equal to the opposite interior angle over there. So stuff like this, like you're better off just, you know, off the bat, just putting that information in, because as long as they've told you that you're dealing with a cyclic quad, you need to remember information about a cyclic quad. So this whole thing here is also going to be 72. Should not forget that. Because this part here is equal to 72. An exterior angle of a cyclic quad is equal to the opposite interior angle. Furthermore, they've told us that these, let's see what else they've told us. Well, we have to read some more, obviously. And then it says with DE parallel to GF. So that's also important because of things like alternating angles, corresponding angles, and all that, co-interior angles. And then they said here D is produced to R. D is produced to R. T is another point on the circle. Where's T? There. T is another point on the circle. It says here EG, and FT. So it's EG, FT, and ET. They're just lines that they drew. And then so any point where you see it's not labeled, it's basically useless. You don't have to worry about it. And then it says here E4, which is this point here, or this angle rather, is 72 degrees. G1, which is this tiny part here, it is equal to 16. Okay, looks like we are dealing with quite a nice and, you know, reasonable sketch. For 2 marks, they want us to get the angle DGF. Where is DGF? DGF, the full thing. Okay, you see that's 72, as we said. So this is going to be equal to 72. Or rather, let's give a statement. Let's say this is equal to E4, right? The reason is exterior angle of a cyclic quad. And then here you can say, therefore, DGF is equal to 72 degrees. 9.1.2, we need an angle for T. Whew, we need an angle for T, right? We need an angle for T. So getting an angle for T, it's not going to be too difficult. Let's see what's the mark allocation here. Mark allocation is like 2, so we don't want to overthink it. So the fortunate thing is when you're going to get an angle for T, don't just jump towards, okay, fortunately T is easy because T is actually also equal to, what you call, this is a ten-chord theorem. Oh no, there's no tangent here. Wow, I was about to get caught there, yo, big time. But T, right, is equal to this part here because angles subtended by the same chord. So what we can do is to get G2. Fortunately, we can get G2 because we know that the whole thing here is 72, right? And this portion is 16. So 72 minus the 16 is going to give us G2. And then once we have G2, we'll have T. So if you look at what we did, we went to T, found out what T is equal to, and then got an angle there so that we have a value for T also, you see. That's normally the trend, you know, whatever they ask, don't focus too much on it because everything else is where the action is. So let's see what we have to write down all that we have figured out here. So T, we said it is equal to G2. What's the reason? The angles subtended by the same chord or angles in the same segment. Angles in the same segment. So if these angles are in the same segment, it means they're equal. So let's get G2. G2, we said G2 is technically going to be 72 minus 16. See, so G2 here is equal to 72 degrees minus 16. See, because of our sketch, or rather, I need to give something that's, you know, gonna be at least, you know, meaningful. So if you don't worry too much about what you write, you can always make sure you put out a statement first with some kind of a reason. So G2 here, we know it is technically equal to the angle DGF there, DGF minus G1, you see. Now you may be asking, but what is the reason for this? I mean, it's given, it's literally given that G2 is going to be the whole thing here minus that. It's a given. It's part of the sketch. So even writing it out is actually weird, you know, because it just is. So this is 72 minus 16, right? Let's get this into the calculator. 72 minus 16, this is like 56. 56? Wow, that looks so weird. But yep, it's 56, man. It's a weird answer, really, but I can't argue with that. Yeah, it is 56. So here you can say, therefore, T is equal to 56 as well, you see. So let's move on. They want us to get GEF. Where's GEF? GEF. Oh, don't assume it's 90 because we don't know if this is the diameter. They want us to get this whole thing. So the question here, we may have to work out this whole angle bit by bit, meaning maybe we get this small part and then we get that small part, or we can just get the whole thing together. But then normally what you want to do is any questions that you would have worked out, right, try to put them on the sketch, you know. So for example, since we have this 56 that we worked out, put it on the sketch, you know, so that you can just see what you actually have and what you don't have. The reason for doing this is if you look at what we now have now, other thing is you see how this question is literally at the end here. There's no question after this for this sketch, but we haven't yet used our parallel lines. That's obviously a big hint that we should try and make use of our parallel lines to get us this some way, somehow. So fortunately, this is 56, right? What we also know is that this is also equal to 56 because of alternating angles. You see. Now, let me actually put this pink in green. Now, this is going to be easy to get because opposite angles of a cyclic quadrilateral, they add up to 180. So if we know that this is 72, then we know what this whole thing should be. And then we can just remove 56 and get the green one, you see. So let's do that bit by bit. Firstly, let's tell them that E1 is equal to G2 because of alternating angles. E1 equal to G2. The reason is alternating angles. Furthermore, we need to tell them that the whole thing here, which is like DEF, right? DEF plus DGF. Yeah, let's do that. DEF plus DGF, right? We have to tell them that we know that this is equal to 180 degrees. The reason for this is opposite angles of a cyclic quad. And then what do we have to do next? So since we know that these are opposite angles of a cyclic quad, they add up to 180. What you now do is put values into your equation, you see. So DGF is 72. 72, 180, DEF. If you work this out, remember the statement reason, this is more like from coming out from what you wrote out. So this is going to be 180 minus 72. What does it give us? 180 minus 72. This is giving us 108. Woo, is good, eh? That's wrong, eh? So 108. Hi, man, come on. It's not writing. 108. That's DEF. So as long as you have DEF now you're home free, you see. Because what we know is that EFEG, or what do they call it? They called it the other way around, GEF. So what we know is that GEF plus E1 is the whole angle there. You know, it's just a given. So let's write it out. GEF plus E1, yeah, GEF plus E1 is equal to DEF. Plus E1 go to DEF. This is more of a given. And me writing it out, yeah, it feels so unnecessary, to be honest. So here, the angle GEF that they want us to work out, let's go to the 56 here. This is technically going to be, what is this angle now? We worked it out to be 108 minus 56, of which 108 minus 56, what does that give us, maybe? Oh, it's 52. Nice, man, nice. We love to see it. We love to win. 52 degrees. That's the way we like it. Okay, moving on to the next question. Anyways, 9.2 was actually quite simple, but then as you can see, I had like overshot the runway. But hey, yeah, we figured it out. So I'm about to remove absolutely all these things that I had like, you know, put in there to try and figure out the question. But yeah, it is what it is. So the reason I'm showing you all this is because I'm literally trying to give you the idea that sometimes the question, yeah, if you overthink it, yeah, it really does not benefit you. So, oh no, I'm actually thinking to myself, why didn't I just firstly remove all this and then just record the question? Well, I mean, like as I said, I just wanted to make it clear that sometimes it's not as though, you know, you just look at a question and you automatically know what to do. You know, sometimes you actually look at the question, you think you know what to do, but then as you're working it out, it's like it just doesn't happen. So this is the idea with the question like this one. Let me firstly remove all this here so that I can read the question again, because you can imagine I was obviously recording and then yeah, it just didn't work out. But here we are. It says, right, in the diagram, the diagonals of parallelogram KLMN. So there's K, L, K, L, M, N. So it is very important that we remember that this is a parallelogram. Now, what is very, very important about this specific question is the fact that we need to keep in mind properties of a parallelogram. Now, the one major property that we are going to need to take note of is the fact that this is equal to this, and then this line here is equal to this PL here. Fun enough, the more I look at this question, the more I realize that I've actually gone through this question on the main channel, Right Young Brains. And I was literally looking at this question. I don't know, it looked very familiar, but at the same time, I was like, I don't know, man. Let's see. This is a parallelogram, so the diagonals are equal. That's actually the main thing that we're going to use for one of the questions. And then it says here, NL is produced to S. So there's N, where is NL? N, huh? No, man, NM. NM is produced to S. And then it says R is a point on KL. So where's R? R is a point on KL. And it says here RS cuts PL at T. And then they told us that the ratio between NM and MS is 4:1. Okay, that's nice. What else? Then they told us that NL is 32. The whole line here is 32. TL is 12. Oh, excuse me. So for 4 marks, right, they said we should determine with reasons the value of the ratio PN and PT. Now they told us that the ratio here NM is 4 to NM and MS is 4:1. So you can put 4x here and like 1x over there. So this ratio here, you may be thinking because it's 4:1 here, you can automatically say this is also 4:1. We would automatically be able to say that if they told us that these lines are parallel. But because these lines are parallel, we kind of need to get the ratio of NP and PT using other ways. Now, the one thing we're going to make use of is the information they've given us. You see here, they told us that NL, the whole thing here is 32. So NL is 32. And then what they also told us is that TL is 12. So this distance here is a 12. So if this is a 12, it means that this entire length here, I might as well use a different color for that length. Well, whichever way, right? What we know is that NT is 20 since the whole thing here is 32. But let's just write that down first, you see. So what we know is that NT, which is from here to there, it is going to be equal to 32 minus 12, which is a 20. Because that's just how the sketch is laid out. From here to there, this would need to be 20 if the whole thing is 32. As long as we know this length here is a 20, what's useful is the fact that if we're going to work out a ratio between NP and PT, what we need is the length of NP and the length of PT in this specific sketch. So getting the lengths of these two lines, it's not difficult, fortunately. Well, it is if you didn't see if you didn't label these two as equal, then yeah, this whole distance here is equal to this whole distance because diagonals of a parallelogram bisect each other. So let's just tell them that we know that NP is equal to PL. You see, NP is equal to PL. You see, PL, which is then going to be equal to 32 divided by 2, which is a 16. So we know that the whole thing is what you may call, the whole thing is 32. Cut in half, we have 16 here and then 16 over there. The reason here you can even put it as diagonals of a parallelogram bisect each other. You see, we're just trying to say that they cut each other in half. So since we know that these diagonals cut each other in half, that's how we know that this is 16 and this is 16. Now that's very useful to us because we need the length of NP and PT. We can work those lengths out. We don't even have to do anything crazy, you know, because since we know that PT, PL is 16, right? So what we know is, remember, PL, we have space here, PL, right? PL, we know it's equal to PT plus TL. It is equal to PT plus TL. So writing this allows us to work out the length of PT, because remember we worked out PL to be a 16. So we can work out PT here. TL is a 20, they gave it to us. Then here you can take the true, I made a mistake. Come on. No, this is 12, bro. Not 20, 12. So the 12 can go over to the other side. This is giving a 4. So we can also then work out the length of, well, NP we already have. You see, NP we already have, remember, it's a 16 also. This is a 16 and this is also a 16. They are both equal, they're equal to each other and they are both equal to 16. So since you have since you have PT and NP, right? You know that therefore the ratio of NP over PT is going to be equal to 16 over 4, which is just 4 to 1, you see. So that's how it's a coincidence that the ratio here is also 4 to 1. But then because this is also 4 to 1, it then just means that these are parallel to each other. But for now, let's just write down our answer for this question. Therefore, the ratio between NP and PT is equal to 4 to 1. There we go. They will give you 4 marks. This question is definitely familiar. So if you look nicely, right, this is the main YouTube channel, remember. See, this is the main YouTube channel, Right Young Brains. If you search on the videos that have been uploaded, you see, about a month ago, we were working on a proportionality. This was a proportionality grade 12 Euclidean geometry small error exam question. So what I was trying, the funny thing is, right, you see with this kind of a question, it's the exact same question. The question in this past paper, this 2022 exam paper, is literally the same question that we did on the main channel. Like, look, it's the exact same thing. It literally just has different labels there. You see, they gave us a parallelogram. They gave us this value here. Then they also gave us PQ. But it doesn't matter if they gave us PQ or not. It's the same sketch. Look, there are 2 lines here. There's a line there. There's a line there. It's literally the exact same thing that we have over here. The parallelogram, 2 lines, a dimension given over there. They just didn't give us anything else. But then it's the same thing, you see. So what I'm trying to emphasize is the fact that the examples that we go through on the main channel, right? We don't just pick them randomly. We pick out examples that are somewhat examinable, things that we know look difficult and are worth knowing, you know. So anyways, that's just a shameless plug, but I think forget it being a shameless plug. It's also a way of saying that the things that we do upload on the courses website, it's different kinds of questions that we know are examinable, different kinds of questions that we can look at and we were able to say, you know what, this kind of a question is not very straightforward, and it is the kind of a question you're likely to get in an exam. So that's what you find on the past papers channel. I mean, that's what you find in our website where we upload the online courses. The link to that is in the description. Anyways, it says here for 2 marks, 9.2.2, right? Prove with reasons that Km is parallel to RS. So this is why this is just a 2-mark question, because the heavy lifting has been done, you see. The reason why this is just a 2-mark question, we need to prove that what? Km, it's the whole line here. Km is parallel to RS. So to do that, we're just going to make use of this. You see, we know that this is the ratio up here is 4 to 1, the ratio down here is 4 to 1. So let's just tell them we know that. We know that they told us that Nm over Ms is equal to 4 to 1. This is given. And then here we know that Np over Pt is also equal to 4 to 1. That is also given. You see. Therefore, Nm over Ms is equal to Np over Pt. As long as this ratio is equal, it means that, remember, we have just basically shown that Nm over Ms is equal to Np over Pt. As long as those ratios are equal to each other, then it means that Pm is parallel to Ts, or rather the whole line there is parallel to the whole line over there, you see. And then our reason would just be proportionality theorem. See, so here, therefore, Km is parallel to Rs. The reason is You can actually just say converse of proportionality theorem. When you say converse of something, you're trying to say that you have spotted the theorem the other way around, where as long as the ratio stands, it means that the theorem is basically something we would want to take note of. Because you see here, they did not, what I'm trying to say is, firstly, we know the ratio is matching. The ratios are matching, so the parallel lines have to be there. Usually we're given the parallel lines and then we're able to write out the ratios. You see? So because it's the other way around, where we have the ratios first, then in a situation like that, if you're making use of this ratio, if you're making use of these ratios, right, to write out that these are parallel, you can just say the converse of the proportionality theorem. 9.2.3, 4 marks. They say here, if Mn is 21 units, determine with reasons the length of RL. Let me start again. If Mn is 21, determine with reasons the length of RL. Where's Mn? Mn is this one here. They are saying determine with reasons the length of LR. So to be honest, the one thing I'm already thinking of is something that I was thinking of when I first looked at this question. If you look at where LR is, right, and if you look at where NM is, funny enough, okay, let me just tell you what is on my mind based on the error I had made in that other question, you see. So with this question here, do this. We have here R, L, there's N here, there's S there, you see. And then in the middle here, there's T. And then somewhere here, we have M. See, but the M doesn't matter for now. What matters is these two triangles here, right? Remember, because we have parallel lines here, as long as we have these parallel lines here, it means that these two triangles are similar, because this angle is equal to that one because of alternating angles. And then this angle here is equal to that one also because of alternating angles. And then the ones in the middle there, they are equal to each other because they are vertical opposites. So we know that these two triangles are similar. Now, the one thing that I am thinking of is, if you're going to get the length of LR up there, fortunately, it looks as though what we can do first is to write out an expression that will give us, different ratios. Now, what we know is, what do we know? They told us that that Mn is 21. So as long as we know that this is 21, but we have the full ratio here, we technically have the full length of NS. We can work it out, but without like saying too much, without like actually, writing stuff. Let's just firstly prove that these are similar, and then you'll see the method to the madness just now. So let's prove that these are similar first. Let's do that. Let's paste this thing here, make this bigger. So the reason behind why we want to prove that these are similar first is because we want to firstly have different expressions that we can use to help us to work out the length of LR. So those different expressions that we are going to write out, right? The reason why we want to prove that these two triangles are similar is because we want to take advantage of having the whole length NS here, because it looks as though NS is going to go with LR one way or the other. So let's use that information. And the reason why we're focusing on NS is because along this line here, we have the ratio between portions of that line. Remember, with this long line here, NS, well, we know that the ratio here is 4:1, and they've given us this distance here. They've given it to us as 21. So we're trying to make use of the information they've given us to work out what they're asking, you see. So this is equal to this one here, and then we said this is equal to this. So let's just tell them we know that. So we're going to firstly state which triangles we're working in, you see. So here we can say in triangle, let's label the bottom one here T. Let's label it T, TNS, triangle TNS, and triangle TLR. So with that being said, right, in these two triangles, we're trying to show that they are similar. So anyways, we're going to say triangle RTL is equal to NTS. NTS. The reason for writing this out is vertical opposites. Vertical opposites. Now, as long as these are vertical opposites, I mean they're equal. Secondly, we can say that LRT is equal to NST. The reason is alternating angles. We can say the same for TNS and RLT. They're also equal because of alternating angles. So let's tell them we know that TNS is equal to TLR. The reason is also alternating angles. As long as we know that all these angles are all equal, we can state that therefore triangle TNS is similar to triangle TLR. The reason there is just angle. Perfect. All those angles are equal. As long as all those angles are equal to each other, we are in a good spot now, because now we can say the following, which will eventually help us work out LR. So with all this being said, right, we can say here, Tn over TL. Tn over TL is equal to NS over LR. NS over LR, which is also equal to TS over TL. I mean, TS over TR. TS over TR. The reason there is just proportionality theorem. Okay, so with this being said, right, remember we're trying to work out the length of LR. So since we're trying to work out the length of LR, remember they gave us MN. Now MN is from here, N, there's M somewhere here. So MN and MS, it's the whole line NS there. But anyway, so what I'm trying to say is amongst these three, so we need to work out LR, right? So we might as well make use of this ratio. And then because we need to use two of these, at least two of these can be used. You cannot use all three. So amongst these ratios that we wrote, we need to pick out which two could potentially help us. Obviously, you want to pick out ones that have, dimensions and all that. So we have, I think TN and LT we have. If you look at our sketch, where is LT? LT is given. TN we also have, remember, because it's like 16 plus the 4 there that we worked out. Remember, we worked this out to be a 4. This one worked out to be a 16. So we have NT and we have TL. So it means we can use these here. These three is what we can use. Or rather, these two is what we can use, because these two we have, and then here we're looking for LR, you see. So let's use these here. So NT, we know that according to our sketch, NT is like 16. No, they gave it to us even. It's 20. No, they didn't give it to us. We worked it out. NT is 20 because it's 16 plus 4. Let's see. 16 plus 4, which is a 20. Just erase that. LT or TL, we know it's a 12. NS, we don't have NS and we don't have LR. But then with NS, right, it's best if we write it as NM plus MS. The reason why it's best if we do that is because of the ratio that we're given. They told us that NM, and the ratio between NM and MS is 4:1. This is useful because as long as we have the actual length of MN, we can then get the actual length of SM using our ratio there. So the easiest thing you can do for yourself is looking at NS, right? We can write this as NM plus MS, the whole thing over LR. And this is 20 over 12, you see. But we didn't even have to do this. We can actually just get NS first and then just throw the whole thing there. So to get NS, or to get whatever this is, we have to think creatively, right? Not really. So we know that the ratio between I feel like I'm writing it again, ms, what is it? No, mn and ms. Let's use our ratio to get what we need. So the ratio here, nm to ms, is equal to 4 to 1. So what we do know though is that with this being written out, it means that nm over ms is equal to 4 to 1. So we have the length of mn, they gave it to us. It is 21. So up here we can put a 21, and then we can actually get the length of ms, you see, because this is our ratio in its simplest form, you see. So it's 4 to 1. So if the length up here is 21, the one down here is, we'll see what it is. Let's just work it out. So if you cross multiply here, it's 4 ms, 1 times 21 is 21. Divide both sides by 4, our ms is 21 over 4. What is that length? Well, obviously it's gonna come out as like 2.5 point something, but you can just write it as 21 over 4. 21 over 4. 21 over 4. Okay, so now we have ms, and then now we have mn as well. So this is going to be 21 plus 21 over 4, the whole thing here with LR, and then 20 over 12. Okay, so at the top, let's see what number that is going to give us. So because we have to just simplify slowly but surely, if you see that your number is like, working out. So at this point, you definitely don't want to panic since everything is just working out now. So this is 105 over 4, and then LR as the denominator. LR as the denominator, and then this is still just 20 over 12. So remember, here you can just cross multiply. LR times 20 is just 20. Hey, why am I writing out of space? I thought I'd given myself enough space. Clearly not. Clearly not, my guy. Clearly not. So I don't let me just make this a bit smaller so that I don't have to wow. Excuse me. I'm just trying to create some space here. So let's put this up there. Okay, let's write here. So here we're going to cross multiply this. Remember, this is a number on its own here. This number is on top, right? This fraction here. So if you current cross multiply, it's 12 times the 1 of 5 over 4 there. So let's see here times 12 there. That's like 315. So it's going to be here 315. Then 20 times LR is 20 LR. Then divide both sides by 20. Then I have here LR is equal to 63 over 4, which is not bad at all. 63 over 4. So these lengths, they may look a bit crazy-ish, but I mean, it is what it is, It is what it is. We do not want to panic. But then we can test out our answer. No, what do we test out our answer? Well, whichever way, I think we did the best we could. Our answer is okay. So the only crazy thing is, okay, there's nothing crazy about this. It's just that we're dealing with fractions. But then, I mean, whichever way, all the things that we did here is basically the train of thought that you want to have when you work out a question like this one. The reason why I think it's out of 4 is because you see, proving similarity here, it's really not difficult. Everything is practically given. And then writing out our expressions there. And then here we just wanted to do things nice and slow. See, we got ms, and then we have nm, put that there. It's all good. So let's move on to question number 10. So question number 10 is one of the most annoying theorems to prove out there, like literally one of the most annoying theorems. But then anyways, the question itself, right, has what was actually given is this triangle like this with this here and this there. This line was not there. It was just drawn from, during the test. This one is this is also what was given here. Well, this is just a, a proof. So I doubt many people are gonna watch this question. But then I'm like, if you're here, welcome, welcome, welcome. How's it going? How's it going? I'm like, redrawing this is absolutely not necessary, right? So let me actually make this white so that at least it's like a bit, you know, a bit clearer. Like, I don't even know why I made it black. It's like, bro, come on now. Let's make this white. Perfect. Anyways, this question, right? It says in the diagram, A, B, C, and D, E, F are drawn such that A is equal to D. Okay. B is equal to E. C is equal to F. Then they said use the diagram in the question book to prove the theorem which states that if two triangles are equiangular, then the corresponding sides are in proportion. For example, you need to prove this expression. You need to prove that AB over DE is equal to AC over DF. So, to be honest, out of 6, it's out of 6 because with this question you actually just do a lot of writing, and I don't know why I didn't give myself enough space, because this is literally not enough space. But snap. Anyways, with this theorem, it's all about making a construction, and then okay, this is what you can do. You want to construct this line in your triangle, but then this line, let me put it this way. Let me make things a bit easier. With this theorem, all you want to do is, you see this triangle here, right? You literally want to redraw it inside this one using whatever dimensions you have here in there. That's what you want to do first. And then once you have gotten this triangle in there, you want to use the proportionality theorem to write out expressions. And then when you're done, you'll eventually end up with this. Like in words, it's all may sound weird, but in practice, you'll see it's even dumber, or it's just weird. But let me stop complaining. Anyways, the first thing you're going to do is you need to construct this line in your triangle. But then this line has to be the same length as EF. Furthermore, this line here has to be equal to that line. And then this line here has to be equal to that one. So let's write that down. So the first thing you're going to write is construct. Let's label it KC, right? Construct KC equal to EF such that AK is equal to DE and AC is equal to DF. You see, so there's your construction. You see, our construction, there's 3 main things: 1, 2, 3. Okay, these 3 here, we are mainly going to be using this triangle now. You see, the moment you draw this line here and you've mentioned that these dimensions are the same as these dimensions, you can now just focus on this triangle. You see, so as long as you've done that, what you can then now do is you need to go further and say that the angle here is equal to the angle over there. You see, because of your construction. And then obviously the angle here is going to be equal to the angle over there because of your construction. So you need to tell them that. So here we can say here AKC is equal to ACK. No. Snap, man. Oopsie. So I meant to say AKC. You want to say that it is equal to AKC. You want to say that it is equal to DEF. DEF. The reason is your construction. Literally, it's dumb. And then here you want to say that ACK is equal to DFE. DFE. The reason is also your construction. So Now we know that this is equal to this, and then this is equal to this. So as long as you've said these pieces of information here, the sketch on the right is almost obsolete now. We're not gonna necessarily use it for a while. So with these two pieces, with this being said, right, this is what we can now write out. Now we can basically, because this is equal to this and this is equal to this, it means that these are equal and these are also equal, you see. So as long as we know that, right, we want to now make use of the proportionality theorem to be able to write out expressions within this sketch. So we need to also tell them that this line is parallel to that line, you see, and these are going to be parallel, fortunately, because these are equal and because these are equal, see. So let's just tell them that. It's quite dumb, but you have to do what you have to do. So here we can say that AKC, therefore we can actually say therefore AKC is equal to KBC. KBC. The reason there is, fine enough, you can just also say construction. You see, because of your construction over there, and because these are all equal, and also because of these statements here, I mean, we already know that as long as this is equal to this, right, then it automatically then just means that this, I mean, this is equal to this, they gave it to us, and we say that this is equal to that. So, I mean, they're both equal to the same thing. So they're equal to each other. Anyways, with all that being said, we can now write out proportionality expressions, and then we'll be done with it. So what you want to take note about what we're trying to prove here is, you see here they spoke about AB, which is the whole thing there, and then DE, which is the small one. And then here they spoke of AC, which is the whole thing there. And then here they spoke of DF, which is the small one. But then I'm realizing that there's two angles that are labeled C. Ah, snap. And we cannot have that. So I need to change one of them. Let me actually just do it quickly. So wherever I mentioned C so far, let me remove this last statement here for now, and I'll be back. So because I labeled two like angles C there, I need to, let me just change one of them. You see, let me change this one. So A, B, C, D, E, F, G. Let me label this one H. Label it H. I literally took what was on the sketch and I went with it. Hey, snap. So wherever I wrote C here, I'm gonna replace it with H, so that our question can still make sense. So let's label this H, label this H, label this H. And then here also, I need to label this H. Otherwise, it's gonna be a problem. So let's see if our question still makes sense. So we said here, we have to construct KH equal to EF, fine, such that AK, so there's AK there, is equal to DE, fine, and AH, equal to DF, perfect. And then we said here, AKH is equal to DEF, perfect. And then we know that AHK is equal to DFE. Okay, everything is fine. So I think I'm leaving all this in the recording because I also basically think this is an opportunity to show that if you have labeled two things the same, it's not going to work. You have to make sure that each point on your sketch has its own name. So AEF here, all those letters are taken. ABC is all taken, so we cannot label this KC because C was taken already. But we have just rectified that, so hence why you see I put that a different color there. But anyways, with that being said, now we can rewrite what we had written here. We want to say that AKH is equal to ABC over there, ABC over there because of our construction. construction. So as long as we have shown that these angles are equal to each other, or we know it, we're able to then say, therefore, AH is parallel to BC. Therefore, AH parallel to BC. So everything is now ready for what we were saying, for what we were talking about. Remember, we said here, what we're trying to prove here, we can see there's AB here for the big one over DE for the small one equal to AC for the big one over DF for the other one. So you see, to end up with this expression, we have to use this sketch only. Take note of the fact that DE here and DF are these small ones here, but then fortunately, the DE here that we have is equal to AK, and then the DF here is equal to AH. But without wasting any time, what we're going to write out is that AB over AK, AB over AK is equal to AC, remove these arrows here, is equal to AC over AH, is equal to AC over AH. The reason for this is just proportionality theorem. You see, so remember, AK is equal, AK, right? AK is equal to DE, and AH is equal to DF. You see, so when you see AK here and when you see AH here, you can just replace that with DE and DF. You see, again, because of our construction. That's why this theorem is the dumbest one to prove. Not dumb, like it's easy, but it's just annoying because the whole thing it just has like this really weird, things here. So with that being said, we can then just write here, therefore, AB over DE is equal to AC over DF. You see, because this is equal to this one, and then this one is equal to this one. See, construction. It's the dumbest theorem there is, like literally. It's kind of annoying, really, this one, because you have like different memos that have things that are all similar, but then it's always about construction. I think this is one of the things that makes some maths a bit annoying, because it's like, what, really? But anyways, hey, let me stop complaining, really. Let's just move on. It says in the diagram, right, O is the center. Oh, perfect. So as long as O is the center, we have a gang load of information. So things like this is the radius, also the radius. So we should not forget that. Fortunately, we can also see this is an angle at the center, this is an angle at the circumference. They are both subtended by the same chord. So automatically, just by looking at our sketch, I know we have just read one statement, but we have gotten all this information, which is quite necessary, because that's how, for example, things like Dr. Cape Town come into play. Whenever you read a description, when they speak of the center, it should remind you of theorems that work with the center, you see. So already now you also know that a center is a point that the diameter passes through. So as long as you're thinking of that, you already know that if this is a diameter, it means that the angle here is a 90-degree angle. You see, more information everywhere. So stuff like this, right, don't take it for granted. It then says here, it's a circle passing through A, B, C, and D. Okay, A, B, C, and D. EF is a tangent. So as long as they speak of a tangent, don't just read it and move on. No, you have to read it and look at the theorems that deal with tangents. So we have the 10-chord theorem, meaning this angle here is equal to that one. You see, there's a tangent and a chord, and this angle is subtended by this chord. You see, so that's the 10-chord theorem. And then furthermore, there's a tangent here and a radius. A tangent and a radius, they'll always meet at an angle of 90 degrees, you see. So there's another theorem here. This angle here is equal to 90 degrees because a tangent will always be perpendicular to a radius. So much information. This question is just buzzing with information, like legit. So I put that there so we can always remember it. There are just theorems everywhere here. So you can even for yourself, even on a small piece of paper, like on your answer sheet, as you're reading and just spotting theorems, you can even write them down. You see, so here we've spotted, angle in semicircle. We have spotted angle at the center of the circle. At center, we have spotted, red eye. We have spotted 10 chord theorem, 10 chord. We have spotted tangent perpendicular radius. You see, all these, one or the other, we're basically we're probably gonna make use of all of them, like legit. So let me write this a bit better, because hey, come on, my guy. Okay, moving on. It says here, yeah, this is a tangent to at E. F is a point on EC. Where is F? F is a point on EC. This is a 90-degree angle, so that's useful. Then they say the radius OC, or rather, radius CO produced bisects AD at G. So that's another theorem here, because a line, if it bisects a chord in half, it means it bisects it at an angle of 90 degrees. So that's another theorem. You see, line from center of circle, line from center of circle. So let's see how many theorems we've spotted in here. 1, 2. This is not a theorem, it's more of a reason for something that we can use, 10 chord theorem, tangent perpendicular radius, and from center. That's like 5 theorems. That's almost 50, that's over 50% of all the theorems that you kind of have. There is no cyclic quad here, but then a shape here might be a cyclic quad, but it doesn't look like it. Doesn't look like any of these shapes would be a cyclic quad. But anyways, let's see the questions. The questions are saying 3 marks, prove with reasons that BF is parallel to CG. Where is BF? BF parallel to CG. So if these are parallel, it means we need to have corresponding angles, and we do have corresponding angles right here. This and this is both equal to 90, because this is a tangent, this is a radius. So this is 90, so we can tell them that. So let's see here. Let's tell them that. So FCO, we know that it is equal to, or let's just tell them it is perpendicular. No man, come on. Let's just write that FC, or this, it's part of the tangent, right? FC is perpendicular to CO. The reason is tangent perpendicular radius. So as long as this is, as long as these are perpendicular, right, then we can say FCO is equal to 90 degrees. See, and then here we can say, therefore, F1 is equal to FCO. Therefore, FB is parallel to CG, because corresponding angles are equal. Because we have spotted corresponding angles that are equal. You see, so because come on, because corresponding angles are equal. 10.2. Whoa. There's A and then there's B. Okay. 5 marks. Yo. Wow. Oh, plenty of space. They say we should prove that 2 triangles are similar. FCB. Where is FCB? FCB. Okay. We should prove that this triangle there. I feel like here we have to kind of get the sketch, so we don't keep scrolling up, down, all the whole time. Let's just zoom in here, zoom in there, zoom out. Yeah, let's see. So with what we have here, right? That's what we have. it says the following. What does it say? Dogo. Oh, we had to prove similarity. Which two triangles now? So we have to remember our theorems, right? They said FCB, FC Barcelona. FCB is this triangle there, and then CDB. Where's CDB now? C, D, and B. Oh, that's not too bad because of the 10 chord theorem that we spotted and the angle in semicircle. You see, our theorems are coming to help us because this we said it's 90 because angle inside half a circle, you see, angle subtended by the diameter of a circle. That's why this is 90. This is 90, it's been proven or it's given, and then, or not proven rather, it was given to us. And then what we also said is that this angle is equal to that one because of the 10 chord theorem. So in terms of proving that these are similar, it's very simple to do because proving similarity, you just have to prove that two sets of angles are equal. And then the third ones, you say that they are equal because of interior angles of a triangle, you see, which is technically this one and this one. So in these triangles, we're gonna say here, might as well even write it up here because I gave myself all the space that I'm not even gonna use. Like, wow, bruh. Well done, man. Well done. Let's see. So here we have to say this is 90, right? So this is like BCD. So BCD is equal to 90. Reason is angle in semicircle. And then we have to say that this is 90 given. F2 is equal to 90 given. You see. Therefore, BCD is equal to F2. That's the first pair of angles that are equal, these two. This, we're going to say that C1 is equal to D2. So let's see here. C1 is equal to D2. Reason is 10 chord theorem. Moving on, what is next? So as long as two pairs of angles are equal, we can say therefore these are equal because of interior angles of a triangle. You see, so B2 is equal to B3. B2 is equal to B3. B2 is equal to B3. The reason is interior angles of a triangle. You see, because remember you're working with two pairs of angles. You're working with two angles. So if you have proven that two pairs of angles are equal, these two are equal to these two, then the third ones automatically have to be equal. You see, since you're proving similarity. So since you've proven that these are equal, all three are equal to all three here, you can then just write that. Therefore, triangle FCB is similar to triangle CDB. The reason for you having to have proven that they're similar is just angle, which is always the reason. Moving on, they said for 1 mark, give a reason why G1 is equal to 90. Where's G1? G1 equal to 90. Oh, the theorem number 1, guys. Come on, man. So let's say a line from center bisect chord. Line from center bisect chord. Nice. Prove with reasons that this is equal to this for 5 marks. Trust me, this previous question was most probably a hint for what we're doing now, and probably even, let's see these two triangles here. There's F and B. Let's see here. Well, let's see. We've proven similarity between these two triangles, so this might be helpful to us in the question that they want us to work out. Like, that's usually just the trend, you know. So let's just keep this close. And then let's also keep the sketch close, because if you can see where these lines are in your sketch, you're usually in a good spot. So let's see here. Let's keep our sketch close. Let's keep our similar triangle stuff close as well. So let's see which lines these are. Before we worry about the expression, CD is which line now? Okay, so this long line. It's in one of the triangles that we proved similarity. And then CG, where's CG? Uh-oh. Yeah, ne? Just escalated quickly. Things just escalated. CG is this random line here. But fortunately, where's the next one? BD. BD is also from the line that we proved similarity. Let me try and make it distinct, maybe like a red. So because two lines are coming from one of the triangles that we proved similarity with, yeah, you may not want to take that for granted. So we might want to dig a little bit into that, because why not? Why not? We might just get lucky. It's a 5-mark question, so yeah. But the other thing is CD is a line, if you look at it nicely, right? I'm like, where there's fuel, there's definitely fire. So if you look at it nicely, right, CD squared here. If you look at these two triangles, right, let's say this triangle here and this triangle here, right? They both technically have CD in it. So yeah, this may be, these two triangles, you may want to see if you can prove that they're similar, because they might just be similar as well, because fortunately they both have a 90-degree angle there and there. So technically, I mean, if we're just like assuming before actually proving, which we can, not to say we can use assumptions. No, what I'm trying to say is if we're trying to think and see how these two triangles could be similar, like this one here and this one here. So technically this angle, right, for the one triangle would need to be equal to this one here for the other one. And then yeah, you can see it's a bit of a mess. Yeah. So what I'm trying to say is D2 for the triangle here would technically be equal to C3 there. And then lastly, the whole angle here for the one triangle would need to be equal to that angle there, which is B3. What a wow, man. What a wow. So how is that even gonna come out? So we need to think of, let's see which theorem. Remember, let's think of the theorems we wrote. We wrote angle in semicircle, we did that already. Angle its center is double angle its circumference. Okay, this is equal to this. Definitely, because this is an isosceles triangle. Oh, perfect. Yes, we can crack this. Nice. This is an isosceles triangle. So this definitely is equal to this. And these are both separate angles from the two different triangles. So this is what I mean with these two triangles. It looks like we can label them. Let's label this one CDG. Triangle CDG, right? Let me see here. CDG and triangle CDB. In these two triangles, we are going to say, firstly, G2 is equal to BCD, which is both equal to 90. That's already been proven. You see, that's how you can write the statement, you see. So we've proven that one pair of angles are equal, the blue ones. The next angle is angle BDC for the one triangle. BDC for the one triangle, right? BDC for the one triangle is equal to, let's maybe not write that statement first. Let's firstly tell them that we know that these two angles are equal, because, no, we need to first tell them that these two lines are equal because they are radii. So OC is equal to OD radii. You see, so as long as those are equal, we know that therefore this angle for the one triangle, right, GCD is equal to BDC. The reason is angles opposite equal side. You see, so we've proven that two pairs of angles are equal. So the third pair is automatically equal because of interior angles of a triangle. You see, so therefore this blue angle here, so this is therefore CDG is equal to CBD. The reason is interior angles of a triangle. Whew, therefore, three pairs of angles here were proven to be equal. So you see, we can here we can then say therefore triangle CDG is similar to triangle CDB. The reason is angle. And then, fortunately, now that we've proven similarity, right, we can write out these expressions. You see, CD over CD over CD. Scary. You see now, that's gonna give us a 1, is it not? Crap. But did I do it nicely now? No, man. CDG and CDB. CDB. Oh, it doesn't make any sense. CDG and oh snap, no. This is not how you want to write these here. You can name these triangles like this, yes, but then this is not named in a way that the angles like match. So you can say these are similar, yes, but then not like this, you see, because that's gonna mess things up. I'll show you why I'm saying what I'm saying right now. So in terms of naming these triangles, right, you wanna remember, we always say try to name them according to the angles that match, you see. So this one, we can name this one CDG, fine, CDG, but then this one, the other one, right, you see, we said we said CDG here, right? For the other one, let's see, where there's angle C here, the other one is equal to angle D, and then where there's angle, let's see here, CDG, then wait, CDG, this one we said it has to be DBC, and here's why. You see, the angle C here, which is this tiny angle, is equal to the angle D of the other one, and then angle D for the one triangle, which is the blue one here, is equal to B for the other one, which is the blue one there, and then G, which is the 90-degree angle, is equal to the C, which is the 90-degree angle there. So if you name it like this, then you can then say therefore triangle CDG is similar to triangle DBC. Because if you name it randomly, yeah, it's not gonna help you. They're similar because of all angles are equal. From here now we can write here CD over BD, CD over BD, no, over DB, bruh. CD over DB is equal to DG over BC, which is also equal to CG over DC. And what's the, so from here, the reason for writing this is just proportionality theorem. Proportionality theorem. So from here, you can see, you can just pick out the expression that's gonna get you what you need, you see, of which this has CD, this has CD, which is gonna lead us to have this CD squared here. So we can pick these two. So CD over DB is equal to CG over DC here. Remember, it doesn't matter if the CD is swapped around. So this, you can cross multiply here. It's gonna give you the CD squared here, CD squared, and then these two multiplied by each other. It's gonna give you the CG and the DB there. CG, DB. Whew, what a wow. Question 10.4, no, 10.2.4. Here we are, here we are. So with this question, right, it's out of 5. Now, the one big hint is that it's asking us to like, it starts with a hence. So any question that starts with a hence, it means that you should make use of the question that you would have just worked out. And we just worked this out, right? We said here C squared is equal to CG. We worked this out. Even if maybe you didn't get it, it doesn't matter. You just have to make use of this to help you work out what is being written here. So the interesting thing with this statement though is it's literally a statement where it has lines from all the 3 triangles that we were actually dealing with here. Because remember, at this point in time, we've dealt with 3 triangles. And technically speaking, all 3 of them are similar to each other. Since if you see here, right, FCB is similar to this, and then this is similar to that same triangle also. But anyways, let's see what these lines are. There's BD here. Where is DB? DB is this whole line here, okay. And then we have CG. CG is this line over there. And then last but not least, we have the FB here. Wow, yo. Such a strange combination of words or letters, whichever way you want to look at it. So if we're going to prove this, right, I mean, to be honest, like the only thing that we can hold on to here is the fact that this question starts with hence. Because as long as it's starting with hence, then it means that we can make use of this some way, somehow. So let's actually even grab it and make sure that it is somewhere very close to us. The other thing is also keeping in mind that we have a lot of triangles here that are all similar to each other. So we'll see what comes out from there. So from here, right, let's see what we have. So I mean, like there's a BD here, okay, so that's very nice. There's a CG as well, okay, it's very nice. Well, here there's CD squared, but then here there's a B, there's a FB squared. Yo, FB squared, FB squared, FB squared, FB squared. Oh, wait a minute. Pythagoras theorem. Yeah. Okay, I don't know if I'm thinking of Pythagoras theorem, but the reason I'm thinking of Pythagoras theorem is because we're dealing with a lot of right angle triangles here. Like, and there's stuff that is just being squared and stuff. So yeah, that might be useful, you know. That might be useful. Like seriously, I think that might be useful in some way. So let's just try and see what we can do. So the fortunate thing is, remember, if you have proven that all triangles are similar, then the one thing you can do for yourself is to write out expressions that accommodate all 3 triangles. So this is what I mean, right? Here, we know that these 2 are similar. So let's just put that there since we know that piece of information. And then we also know that these 2 are similar. So since it's 2 triangles similar and then another pair that's similar, all these 3 triangles are similar to each other. You see, because remember here, we just have to relabel these nicely so that they can work together. So you see here, triangle CDB is the same as this triangle. We just rewrote it. We just have to make sure we write them nicely. But anyway, so here we can say since triangle FCB is similar to triangle CDB, and So this one, okay, I think the way we're going to name these triangles, we have to be careful because that's actually the name of the game, naming these triangles. So let's do this. With all these triangles, right, what we know is that for the first triangle here, the small one here, this is the 90-degree angle. For this one, this is the 90-degree angle. For this one, this is the 90-degree angle. Secondly, we know that this angle is equal to this one because of the 10-chord theorem. And then for the other triangle, which is this one here, this is the one that's equal because these two are equal. So all three of those are equal, then all three of these are equal. So that's a way we can use to help us name these triangles. So you see, we're going to say, yes, since, let's call this one, let's say since triangle, let's see here. Come on, bro, how are we going to name this thing? Let's say since F, B, C, let's say here. So since, or let's start with the main one. Let's start with these, with this one here, since it's similar to both of these. So since triangle CDB, so if you're gonna name this main triangle CDB, so we say this one is CDB, right? Since triangle CDB is similar to triangle FCB, see, that's how that other one would be named, because it's F goes with this, this goes with this, and this goes with this. So since these are similar, try and label this properly. Since this is similar to this, and triangle CDB again is similar to triangle, let's see, so we say here CDB. So CDB is also similar to triangle GCD. See, since this is similar to this and it is also similar to that, therefore all three are similar. See, therefore CDB similar to FCB, that triangle over there, which means that it is also similar to triangle GCD. All three are similar, you see, because you have one triangle that is similar to both of them. So all three are similar. So because this is the last question in this paper, I mean, I think we cannot say we're shocked that it's like this difficult, because it's going down. But anyways, let's see. So we see that, all these three triangles are all similar to each other. So if you think of it, right, we're technically gonna have three sets of expressions that we can write out and say, we're gonna write them all out and then say the reason for writing them out is the proportionality theorem, like literally. But let's work with these two triangles first, right? We already know that CD over FC, CD over FC is equal to DB over CB, DB over CB, which is equal to CB over FC, CB over, no, CB over FB, sorry. Fine, that's the first thing we wrote, right? Using our orange. So, or rather, that's what we did when we used these two triangles, you see. So let's use these two triangles. Let's see what we can write out. FC over GC, FC over GC is equal to CB over CD, CB over CD, which is equal to FB over GD, FB over GD. Fine. And then last but not least, we can use these two triangles. You see, we use these two together and we use these two together, you see. So we have to use these two together now. So with those two sets of ones, so with this and this one, you see, we can say that CD over GC CD over GC is equal to BD over CD there. Let's see, DB over CD here, which is also equal to CB over GD. CB over GD. So all this, the reason is just proportionality theorem. The reason for writing all of these three sets of information, you see, set number 1, set number 2, set number 3, because you see, we have all these triangles similar to each other. So I mean, like, you can see that for 5 marks you may be thinking, but dude, why are we doing so much? It's just a 5-mark question. But the thing is, it's the last question in the paper. Normally the last question in the paper, yeah, it's really the big one, the one that's like all messed up and stuff. So in terms of what we're trying to prove, right, let's see what we're trying to prove. There is DB somewhere, there is CG, and then there's FB. So if you look at it nicely, right, let's see where we have DB. So here there's a DB there. Here there's no DB anyway, right? Nope. And then here is their DB. There's a DB here. Fine. Furthermore, or rather, is there anywhere where there's DB? Let me see. Let me look for BD, because BD is the same as DB. So nope, we don't have. This is the only two where we see a BD. Furthermore, let's see where else do we see CG? Let's check for where we see CG. CG, we see CG here, and we see CG over here. Okay, quite interesting, or is it? And then let's see where we see FB. FB, we see it over there. And then where else do we see FB? We see it over there, and then we don't see it here. So the one thing that we can safely take note of, or the one thing that we can safely all see, is that, you know, in each of our expressions here, expression number 1, expression number 2, and expression number 3, you see, in all 3 sets, there's just 2 of them that somewhat have something that we may need. So let's start with this one. You see here in this expression, we can take these 2 here, right? These 2, and we can do something with them. Here we can take this one and this one and do something with them. Here we can take this one and this one and do something with them, you see. So let's do that. In the first one here, DB over CB is equal to CB over FB, you see. If you cross multiply here, this times this gives you CB squared, this times this gives you FB dot DB. Fine. Let's move on to the next one. These 2 together, right, it's FC over GC equal to FB over GD. If you cross multiply here, sure, yeah, what are we getting? We're getting the FC dot GD equal to FB dot GC. And then let's take that third one here. This third one here, we have CD over GC, right, equal to DB over CD, right? So if you cross multiply here, you have CD squared, and then here DB times GC. Whew. Yeah, it's getting hot like a heater. So further, with all this, right, I feel like the next best thing we can just do is, what can we do? Well, we're trying to have an expression where DB is on its own, right? And then there's CG somewhere, and then there's FB somewhere. So these 3 should be our priority. Let me actually just copy down this expression so that we have it close to us all the time. Now you can clearly see that this kind of equation, I mean, like, it's really one of those where it's not a mystery why it's right at the end, because this is the kind of equation you could spend such a long time trying to figure out. Hence why it's fortunately right at the end of the question, because if you're not done with the whole paper and you're trying to figure out questions like this, you see, you're just going to be wasting your time. But anyways, let's see what we can come up with. I'm pretty sure we're all curious how to end up with this expression. Let me try and make this expression pop. So with what we have now, right, what's the train of thought? We still want to focus on these here. You see, we still do want to focus on these here. So what can we do? What can we do? So in each of our expressions, right, one thing we can safely say is, I mean, like in these two here, they both have like a what you may call a CG there. Is this not what we had proved in the previous question? Yeah, it is. CD squared is equal to CG and DB. Okay, so I feel like one or the other, this may be useful to us in some way. But then now the question is, do we use this to help us or do we use this? So the reason why I think, let's see CB squared and CD squared. Let's see what CB is, because I'm kind of curious. CB is here and CD. Those are in the same triangle. Oh, I think we cracked it. Wait, there's CB and CD, right? CB and CD, these are in the same triangle. So I think we can write out a Pythagoras theorem expression here. Let's see what we can come up with. BD squared plus is BD squared, right? Is equal to CB squared plus CD squared. I think that may be useful. Yeah, let's do it. Let's do it. BD squared. Let me remove this thing here. I just wrote it out here so that we can keep ourselves reminded of what we need to work out, right? This is for 10.2.4. So what I'm writing out now is Pythagoras theorem. BD squared, right, for our one triangle, BD squared there is equal to CB squared plus CD squared because of Pythagoras. CD squared. So with Pythagoras, the reason here is just Pythagoras, right? So what we now know is, fortunately, you see where we see CD here, we can just, let me just color code it. Where we see CD here, we can just write, where we see CD here, right, we can write this thing here. And then for the other one, where we see CB here, we can just write this thing here. So let's do that, you see. So here, BD squared is going to be equal to FB dot DB plus, where we see CD here, we can put this thing here, DB and then GC. Fortunately here, we can take out something as a common factor, you see, the DB here. So we can take out DB out here, there's FB left, DB out here, there's GC left. And this is like BD squared, right? And then we can clearly divide both sides. Remember, BD and DB, it's the same thing, you see. Divide by DB here, divide by DB here, because it's the same thing, you know. Let me actually just write DB twice so that, you know, yeah, because it's just the same line. So this cancels this, and then one here cancels one down there. So then you're gonna have, let's see how they wrote it out. There's, yeah, it's actually DB. Yeah. So there's gonna be one DB here. Since this is gone, you're gonna have FB here and GC there. Wow, we got it, man. We got it. So that's what they have here, you see. We got it. You can even just swap them if you want, just for the vibes. Woo! Wow, that's a crazy formal question. But I think with this formal question, you can see this was more like just a long dry. But then the reason for doing all three of them is because what I was trying to show is that all three triangles are similar. You see, so you might also have three different sets of expressions. And then you saw how from those three different sets of expressions, we just focused on which expressions had these lines, and we picked them out. And then we wrote them separately. You see, it's more like you're trimming down to your final answer. We had like many different expressions first, and then we just had these three sets here, 1, 2, 3. And then we wrote them out. And then from having to have written out these ones, this one was now useless because it does not have anything that can help us. These two, they were meaningful because you see, they both have something squared there. So automatically these two both having something squared, it made sense to work with these two because remember the question said hence. So it means we would need to consider the previous question where we work with something that had a square. So the other thing also is because we're working with shapes that are like right angles, you would definitely want to be thinking of Pythagoras some way, somehow. And then the one thing was that definitely these two lines are in the same right angle triangle anyways. So if we can write out Pythagoras for that triangle, we will have an expression for this and then an expression for that. And then we can put them in the theorem. And then here we have our final answer. Woo! So that was a dope paper. But yeah, this was a difficult paper. I don't want to lie. I'd say a good 40% of it was difficult. The other 60% was, fair. But in general, it was not a very easy paper. It was kind of edgy. Okay, let me maybe say like 35% of the questions were like proper monsters. But it's all good. Here we are. We are done. You can download this PDF file by clicking the link in the description, and then you can just create a free account on our website, and then you can click on enroll for free on that past papers section, and then you can just look for the 2022 papers, and then you can download this PDF file, 100% free. But yeah, it's all good. I shall catch you in the next video. Don't forget to like, share, and subscribe. So obviously, in the link in the description, right, it's gonna take you to the online courses where you can clearly see you definitely want to enroll, because funny enough, I promise you, I kid you not, there are questions in the analytical geometry in the Euclidean geometry course where we showcase how to work with things like this, like literally. Let me show you. So if you look here, right, this is one of the questions in like the Euclidean geometry course, right? You can see here they're asking us to prove this long expression after we had proven that two sets of triangles were equal. Now, obviously looking at it like this, because it's already done, it looks a bit crazy and all that. But you can see how here you see there's three sets of there's like three sets of proportionality expressions here, and then another set here. And then literally you see we like picked out ones that had something from our question, ones that had something from our question, and then here we created like two separate equations. And then from those two separate equations, we wrote out this long thing here, and then eventually ended up with the question, or rather, we then ended up with the answer, which is what is being asked over there, you see. So when you're seeing it like this, it's like, oh snap, it's just like so many things flying around. But remember, with these online courses, it's the same idea. Whatever is written down here, it's questions that we will like work out while it's like whatever's written out here in the videos, right? It's basically explanations while writing it all out, you see. So I'm trying to say that, you see, with these kinds of questions that we were doing here, where we're picking out, things that match and all that. If you've gone through like something like the Euclidean geometry course on the website, then you would be thinking that way, to say, you know what, let me try and have different expressions, and then after having different expressions, let me try and pick out things that we have in our question. Then you tick, 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 and then you filter it out until you have your final answer. But yeah, if you have any questions, you can also just hit me up on IG and just let me know what you think. And then, yeah, man, that's that. I shall catch you when you will catch me also.